Hello everyone. How is everyone doing? Alrighty. So we're nimming today. We're continuing with our driver for the SurrealDB for the nim language. Uh we'll see how we'll do, alright? I don't feel in higher spirits for the nim itself today, but maybe it's gonna change as we go. Who knows? For now, I know that I can show what happened since last time because I did some rework here and there. So first of all, I renamed it I renamed the repository from just Surreal to surreal.nim, just in case. And at some point, it's gonna be, maybe I'm gonna have different Surreal repository or whatever. It just suggests that, okay, this is about nim and this follows the pattern that SurrealDB has with their SDKs, where they have surreal.js, they have surreal some other stuff. Although that's the question, do they have, what do they have it now? Because maybe I need to rename it once more. I mean, we can just search for SurrealDB JavaScript, right? And let's see. What is the name? Oh, it's SurrealDB.js. Oh, so we need to add a DB at the end, right? That would be a bit more like it. SurrealDB.py, SurrealDB.go, and so on, right? .net, .wasm, all those things. So yeah, I guess we'll have to update it a little bit. Let's see if I can do it like straight up here. Where did it go? Can I go to the settings and change the name once again? SurrealDB.nim. Okay. There we go. That should work. That means that we're gonna go and edit our origin to also have SurrealDB.nim. Okay. Update it. We can pull the stuff. Yes, we can pull the stuff. Great. So, there we go. It's SurrealDB.nim. Even better. That means we also have to edit our description here on the stream, just so that we have proper URL and so that that URL can propagate everywhere else as well. Okay. Now we're in style with the rest of SurrealDB SDKs, which is great. Why does it say 20 minutes ago? Oh, maybe 20 minutes ago, sure. So what else has changed, okay? So what else has changed is that I reorganized the code a little bit, okay? So now in the main directory, we have just surreal.nim, which looks pretty much the same. The only thing is that I got rid of all the includes and now we're focusing on imports because we're starting growing size with numbers of files here and how those dependencies are managed, and just having to, sort everything nonstop becomes a bit of a pain. So we're gonna stick with imports. And Tara says, hello to you too. Why does YouTube suddenly out of nowhere shows 5 current viewers? I have no idea, but hello everyone as well. How are you doing, Taras? And how is everyone else doing? I encourage always everyone, just come and chat. Let's have a conversation. Okay, so what changed now mostly is that I organize things a little bit more in directories, okay? We have all the queries in their separate little files, like create, right? They all include shared imports, which you can see is plenty more besides just standard libraries. We include we import our own types like the method, query params, record, result, SurrealDB, Surreal result and table name, and whatnot. So a little bit is going on here. And RPC is that, generic send RPC request that we're going to use that we're using behind the scenes. Okay, so we've got them all separated out. Additionally, we have types. So now we have none separated. I also updated it so it isn't backed by the it isn't backed by the boolean anymore. It's just an empty object. Okay, the same with null. And I just, copy pasted, extracted stuff a little bit more. Although we have a new record ID that can store table ID and string representation separately. And I also added a little bit of logic behind the scenes. I think where you can, oh yeah, record ID as reference object. Okay, great. So basically what you can do here is that you can create this record ID either from a string or by giving it table and ID. And this way it's gonna automatically save whichever that is needed. But if you want to get a string representation of that, only then it's gonna calculate it. Or if you create it from a string and you need a table name, only then it's gonna extract those values and cache them. So it's a little bit smart. And Tara says, doing good. It is Friday. Yes, it is. This time it actually is Friday. I streamed a bit today. I've got a new camera board from my wife. Nice. I got my camera because at some point I needed to do some photogrammetry, and my phone was just absolutely the worst at that because phones apply so many filters. And now it's permanently stuck on a tripod because out of nowhere I decided I'm gonna start streaming. Life happens, right? What did you stream? Okay, so we have, just a type, and we can also make it, like var some ID would be basically RC, and we say some ID, right? It doesn't have an initial verification of that thing. It just creates a type where it shows the past string to string representation. And only then, if I'm gonna say, hey, give me a table, it checks if the table is not set yet, and then it's gonna extract it, which sets everything and tells you. So next time we're gonna reach out for that, it's gonna straight up give you. So that's that. We've got the record ID, and similarly, we have also table name, which is just a distinct string that we can create again from a string. We can compare them, turn to string, and what else? Also serialize. For now, JSON, because everything is JSON until today. And Pancake Dev says, hi, hello to you too. And Tara says that he streamed his day job. Okay, so you have day job and night job? I'm starting to get a little bit confused. How are you, Pancake Dev? Tara says, I have met one guy who, out of spite for WannaCry, started learning about malware development. He sent it to me so I can read the code. Oh, that's fun. Never had a chance to actually go through malware. But at the same time, I don't know if I'm good enough with low-level stuff, unless malware just gets to the point where it's not focused on low-level anymore. It's probably more about networking. Most of it is encrypted. Oh, of course it is. So that nothing detects that it's malware, right? Okay, so what else did we get? We have, RPC method. Oh, another thing that changed. I went through a little bit of the JavaScript library code, the JavaScript SDK for SurrealDB, and I noticed that there are a few things that were in the documentation, mostly version. What else was there? Relate was actually in a different format. There's run for just running a function or some machine learning process. And probably something else, right? So I added those, and I actually implemented those. We have anything else? SurrealDB is extracted a little bit. Surreal result just moved here, and I kind of started making a Surreal types just to have a list of the types that we will probably need to figure out how to serialize it. But I figured, you know what, as today's focus will be to implement the CBOR protocol for serializing and deserializing data instead of using JSON, because it's, you know, a little bit less data going back and forth, and it should be also faster, than serializing to and from JSON. Yeah, then this will be probably limited or expanded by whatever we're going to be doing there. And so that's when it comes to types. We have logics where we have the connection, which is, you know, creating the new connection and disconnecting. And then we have the listen loop separately as a separate file. So it'll be a little bit easier to go around and, you know, wrap our hand like, okay, this functionality here, this functionality is there. And we can ignore nodes. It's all empty. I can actually straight up delete it because it's not anywhere yet. And we have queries, which is basically what it's doing is just exporting all the implemented queries. So I implemented a lot of them. Basically, I added the version, which is nothing crazy. Last stream, I believe we finished at create. I went to insert, update, upsert, relate, merge, delete, and run. And at some point, we're gonna do the patch as well. We'll support sending GraphQL queries and just returning raw queries and whatnot from the database at some point too. But that's when we have CBOR, which will be kind of our new way we are handling data. Therefore, it will involve changing all of that to, you know, by a little bit, but it will get the rest of the thing. Dara says it wasn't Python, and my night job is watching your streams. That's a fun job. All right, cool. So you're continuing to learn NIM, right? It's funny you're watching NIM language streams while not coding in NIM, right? All right. So that's good. I explained that a little bit. So now the thing about CBOR. So whenever I go to some kind of query, like let's say select, right? Where we basically saying, hey, this is the table, either a string or table name or a specific record. We're gonna send that to the database in a way that we are sending the RPC method, and then we're basically converting to JSON that table, and we just wrap it in an array. That's how JSON is expecting that, if we're using JSON, of course. So the thing with that is that we have all this JSON serialization. If we're gonna go into this send RPC, which should be here, we can see that there's even more going on. Here I'm just straight up, not even bothering with automatic serialization, but just I'm creating a string. Like, hey, this is the ID, this is the method, this is parameters, and it's all just wrapped in JSON, and we just add this at the end. And I mean, we just replace some of those parameters. So, like, you know, 1, 2, and 3. So it's all in JSON, but that has several limits. Oh, that's true. Thank you, Taras. Thank you so much. I'm explaining so much without even showing. Rookie mistake. Yeah, so the current problem is that we're serializing everything to JSON. With every request, whatever data we're sending is JSON. And that means that we have a lot of serialization going on. Working with strings, no matter language, it's slow. So our computer needs to serialize the query. Database then needs to deserialize it, do its thing, and then let's say we requested 10,000 records. It needs to grab those 10,000 records, serialize them to JSON, which takes time, send it over network. Network is, I mean, JSON isn't very compressed, let's say. And then we need to receive it and unpack it, which is, again, a lot more just work to extract that. So using something like CBOR, which is, I believe, what did it stand for exactly? That's a good question. It was compressed compressed or contracted? CBOR. Concise binary object representation, okay? So what it means is that instead of us just sending strings, like instead of us sending a number, like an integer, in form of a string digits, which is kind of ridiculous, we actually send the actual number. So we don't have to do those parsings and all the extra work around it. And what that means is that we often can send, a number in a few bytes rather than, several times more bytes just to represent a number or whatever. What it also means is that, for example, SurrealDB has a few extra types of data that you can represent in JSON. Because in JSON you can represent null, but you can represent none. Which, these are two different values in a database where they're kind of equivalent, where null is what null is in JavaScript, while none is what undefined is in JavaScript. So it's kind of, there's no way to represent that. And that already forced us to send some data in a different way than we would like to. And on top of that, we have, geometries. Sometimes a string might mean a date or something else. And when sending as JSON, we're not conveying that, semantic meaning, as they call it. And Tara says, at first I thought that this was a new video format, but then you said here. Oh yeah, that's my bad. Happened to me before. So now that with the CBOR, basically, we'll be sending binary data instead of JSON. So to implement that, we can look at how SurrealDB's official JavaScript library does that, because A, it should be relatively easy to understand, and B, it's implemented straight for that particular use case. So in the SurrealDB.js, in source, we have just a CBOR folder that has a bunch of stuff. And, when we just jump into encoder, it's not that much of code. It isn't cryptic or anything. It's just initially kind of difficult to wrap your head around, especially that I kind of don't feel like reading the whole RPC, whatever, RFC, sorry, the reference, the whole format, because sure, I can read it. Where is it? Specification. There we go. There it is. But to read it, I will probably need to spend 8 hours just reading that to comprehend that. So I'm gonna do what Taras wouldn't do and just replicate the JavaScript code, or in this case TypeScript code, and I now translate from TypeScript to Nim, see where we have some discrepancies, because TypeScript has crazy type system, and hopefully it's not gonna get in our way. We'll see how that goes. And yeah, it's gonna be fun, and we're gonna learn how the thing works for the specific use of SurrealDB by just sampling the code and playing with that. So initially what I did initially is just I created a new Cloud project. Okay. I gave it all the files in JavaScript or TypeScript, and I initially just asked a few questions to start figuring it out, so that at least I have some kind of idea on the stream. And I asked it to draw a nice, not this one, some kind of representation of this library, the dependencies, to start off figuring out what are the loose ends that don't depend on anything, so that we can start implementing them. And first of them was the gap.ts. So we're going to look at that. Gap.ts. We have two types. There are actually questions here. which is interesting. Why is the default value being stored in an array? Yeah, so who knows? But what we have here is a concept of a gap. So as far as I understand, with the CBOR protocol, as you're encoding some values, you kind of wrap them in frames saying like, okay, this is integer, this is string, this is something, this is something. And often you might figure out, okay, this object has 4 elements, right? And let's say the second one is another object. So instead of encoding what's inside there, just say, okay, we're gonna put a gap here that there will be something here, and I'm going on encoding other stuff. And then we just fill it out with a fill, which is basically a tuple of the gap and the actual value. And Tarasis says, oh no, what about examining a C++ CBOR library? It's easier for me to read TypeScript. I'm more familiar with it, and I have implementation that is specifically for SurrealDB, where we have, let's say, encoder that takes care of the specific, not only the normal, like numbers and other stuff that are specific to CBOR itself, but also we have some additional things like, let's say, some other stuff which I'm missing right now. But basically, we have bunch of tags which are defined somewhere else. Can't remember where now. But basically, things like somewhere. We'll get there. But geometries and other things specific just for SurrealDB. So this way I know that if I'm gonna implement it exactly the same way, it's gonna work and I'm not gonna have headaches. And at that point I can just see how the library is changing and maybe kind of replicate that. At least as a first iteration of the library. This way we can just keep moving forward. And again, I'm just learning them, so I'm not that confident in just rolling out the protocol. And never did anything of that sort. So with the gap and fill, I kind of quickly, as a test, already implemented that in NIM. So we have the CBOR folder and I have gap here. So we define the gap that basically can hold a sequence of some kind of arguments. So a gap represents a placeholder and partially encoded CBOR data. It can optionally hold a default value. For some reason, don't know why yet. And a gap has a default value if it was created with exactly one argument. So that's how the code works. And a fill is basically a tuple of a gap and a value. So a fill is used to provide a value for a gap between when finalizing partially encoded CBOR data. And we basically have a way to create a new gap, fill it, as in create a fill out of with the new value, has default, check, and getting the default value. And that's pretty much it. So that's not a lot. So what can we do next? So next we can basically start looking at more, what loose ends we have. Let's take a peek at the encoded.ts. So not this one. And we can make it a bit smaller so that we can see the code. Encoded. So encoded is, in TypeScript, it's a class that basically has a single value, read-only array buffer. So, okay. So this sounds like on NIM side, it could be a distinct array buffer or something like that, right? Because the whole idea is that we shouldn't be able to change anything about it, and it should be read-only and whatnot. So the whole idea of a class in TypeScript, I presume here is so that we know that, okay, this array buffer is already encoded. We're not touching that anymore because it's set in stone, instead of just passing around array buffers that don't have that additional meaning. So that's that. But how on earth do I deal with array buffers in NIM? That's a good question. What does array buffer do for us? Array buffer presents a raw buffer of binary data, which is used to store data for different type arrays. Array buffers cannot be read from or written to directly, but can be passed to a typed array or data view object to interpret the raw buffer as needed. What the heck? I never use array buffers in JavaScript. So I guess this Taras is where it gets tricky versus C++. But okay, so this is basically some kind of buffer, and let's look at uses of encoded. Can I go find our references or something? In an encoder, we check if it's an instance of this thing. Writer, write array buffer, and we just give it the buffer, right? Okay. That makes sense. So we pass that array around to buffers. And we have abstract, whatever that is about. Where is that? Source engines. Oh, that's yet somewhere else where we're using it. We have got types and prepared query. Huh. So, okay, so these are not in CBOR anymore. Interesting. So this encoded is basically used only in encoder to write the data. Okay. Sure. It's funny how we're not ever creating it. Here in prepared query, we actually create it, and we encode query something something to get it encoded. Okay, this is gonna be interesting. I'm already lost in code. Tara says, as far as I know, array buffer in JavaScript is just an interface for low-level performant memory manipulation. Yeah, that's what the name suggests. That's what I believe I heard at some point or read at some point, because it rings that bell. So yeah, so we're gonna start with just an array of bytes or something, because the thing is that we might just start with some really dumb initial implementation, okay? So and then we're just gonna use a sequence of bytes. How about that? Sequence of bytes, this way can grow, can shrink, and we don't have to worry too much about how it's managed behind the scenes. As far as I know, it grows, but and it can change its size. So there's something behind the scenes managing it. I just don't know to what extent it's actually performant, but you know, it's a start. So maybe we're gonna do that, right? Encode it. I'm just gonna straight up copy the code and we're gonna turn it into NIM. So in CBOR, let's create a new file, encode it, right? And we're gonna make a comment with our code. So it's a class, so let's do type encoded, right? And let's make it a reference object so that we can pass it around without copying all the data. Just one instance, okay? And I'm not gonna do comments right now. And what it needs to hold is basically an array buffer. So I'll just call it data, okay? Sequence of bytes. There we go. It already knows what we're doing. So that's that. And now the question is how to create it. Because notice that I didn't make the data exported. So I can see that we should be able to create it by giving it data, but not allowing to write to it. I'm confused a little bit because notice that this says it's read-only. But does it mean that we can't switch it for a different array, or what the hell does it mean? I don't know. So let's just export that and let it do whatever it wants, okay? For now. Let's do already encoded CBOR data, okay? Holds. Already encoded CBOR data. But at the same time, do we need it as an encoded type, as a reference object? How about we just make it a distinct sequence of bytes? So we can convert it to and from a sequence on a whim, but we can say that, hey, I want it to be encoded. We'll try that approach first, okay? What was it? And already encoded CBOR data. There we go. Let's start with that, and we'll see what we need. And Taras says, so in NIM or C++, it could be just memory location. It could be, but here I know that this will be, or I don't know. Huh. We'll see how it's used, all right? Because maybe you're right, and we simply will be able to pass pointers or references, because that's an option as well. Okay. So we've got the encoded, some idea of it, right? Then we've got tagged. What is tagged? Because in CBOR, I know that we have a set of default types of data that we can encode. And I think these are 3 bits out of 8 of the first byte of data represent that. So we have basically 8 values to work with. And if we set a specific value or something, we can actually say, you know what, this type is tagged or something, which has additional data type added to it. Which basically says, okay, maybe this is not just a number, maybe it's something else. So let's look at tagged. So tagged of type T, which by default is unknown. That's something I learned from this library, that in TypeScript, the generic values can actually have a default value, which is fun. So we basically have a tag, which is either a number or big int, which is interesting. Really. Huh. And then we've got value. Okay. I think that's gonna be easy enough, right? Something of that sort. So let's create a new file, tagged.nym. I know it's really dumb what I'm doing, but that's the thing. It's really dumb, so I can kind of follow it and start figuring out how everything works. So we're gonna define type tagged. Okay, it's gonna be again reference object, so that we can just pass it around. We're gonna figure out a comment in a second. For now, we know that it has a tag. Sure. A tag, which is either an integer or integer 64. Is that true? Because big int is supposed to be like really, really, really large, right? But we don't know how it's being used yet, so let's just go with int for now. We're just gonna add a comment and then value of t. And that's all we have. And they are marked as read-only, so that we create this once and then we can only read it. So because of that, I'm gonna do it, specific getters but no setters. And in NIM, the way we do it is we basically define a new procedure that is basically, hey, give me a new tagged, right? That returns us the tag. We just provide the tag and the value. And there we go. We just create it, okay? I mean, you could just call this from wherever you want, but this kind of implies that we, we have more control over it and more suggested, more specific way to create it. And then because the tag and values are not exported from anywhere outside of this file, you can't access those values. It's just not possible. So we need to create procedures for tag that just takes the tag. That's what we can call it on. So I guess it needs the T. I presume at least. Right? And it just returns the integer or whatever. So we just return it. And then the same way we're just gonna go, whoa. Where did the decoder come from? I pressed tab a few times and it created a file decoder on them. What the hell just happened? What? Value? I pressed tab. I don't know where the decoder came from. That's so funny. So yeah, now we can read those values, we just can't save them. So it's read-only, and that's it. Great. And let's ask AI, what does the tag thing do? Okay. What is the reason for the tagged type? How does it fit into CBOR protocol? So we're going to learn some about CBOR probably. The tag type in the provided code is used to represent a CBOR tag data items. Let's examine how it fits into CBOR protocol. CBOR tag data items. In the CBOR specification, tag data items are a way to attach semantic meaning to data. A tag is an integer that indicates how the following data item should be interpreted. Implementation of the code tag class is defined as tags.ts. Yeah, we just read through that. This class holds two pieces. Tag, the semantic tag, a number or big int, and then value, the actual data item being tagged. The usage is an encoding in the encoder.ts. We can see how the tagged values are handled. So if it's tagged, so basically at some point when we're encoding, we're checking if the value that we provided at some point is instance of tag. If it is, we specify that it's a 6. So those first 3 bits are set to the number 6, and the rest is, I guess, the tag or something. And then we recursively set the inner, so we basically go over the value of the tag, the value.value, yep, this one, and we encode that part. So this code writes the major type 6 for tags, followed by the tag number. So the major type 6 is basically saying like, hey, this is a tag. Followed by the tag number, and then encodes the tagged value. Okay. And in the coding, we're basically doing the reverse, right? So if we read that the first 3 bits are numbers representing number 6, then we read the rest as the tag, and we decode the value. And then we just create a tag that, okay, we've got the tag, and that was the value. Whatever it was. Whatever the code returns, right? So when the tag, the major type 6 is encountered, the decoder reads the tag number, then tag value, and returns new tagged instance. There we go. Purpose. The tag type allows the CBOR implementation to preserve the semantic tagging information when decoding CBOR data. This is crucial for correctly interpreting certain data types or structures that rely on CBOR tags for their meaning. For example, CBOR defines tags for dates, big numbers, URIs, and other special data types. By preserving the tag information, the application using the CBOR implementation can correctly interpret and handle those special data types. Tara says, as soon as you are reading TypeScript in Claude, you might as well read some RFC. I started reading that RFC, but it wasn't fun. And I know that with my reading, it will just take me 2 or 3 streams just to read through the RFC before starting any work. And I want to get things done. You know, normally I would just give up and just screw that. I'm not dealing with that. I'm just forcing myself to do something. And I want to move forward. So in the context of SurrealDB, this allows the database driver to correctly handle any custom or standard CBOR tags that SurrealDB might use in this protocol, ensuring accurate data representation and interpretation between the client and the server. So my question is, do you have enough information to tell me why the tag can be big int? Or what was it? Couple big int or something? No, just like that. If yes, please explain. That says the rest is fluff. Oh, so Taz says you don't need much, just 3.1 section. The rest is fluff. Okay, I'm gonna look at that in a second. You're asked about the begin tab. Let's examine more closely based on information. So we see that a tag is indeed defined. However, to understand like how tags are read and written in the decoder, we can see that they are done in that way. R.read major length and length. What is R? We don't know yet. It's got to read the tag value. How? Oh, okay. I see. Let's look at the method. So basically, number or big int. We have that. It's 27, and so we give it the length. Oh, wait a moment. Read major length. Oh, so we probably read the whole thing. We can see that for very large tag values, when length is 27, it reads 64-bit unsigned integer. Its value is larger, which is the largest integer that can be safely represented in JavaScript number, it returns big int. It allows the full range of tag values specified as super standard. So wait, uint64 is a big int in JavaScript? So big int is used to contain uint64. So in a language like nim, I could just use uint64, right? Yeah, uint4 is just 64 bits. Because I think seeing this, because I recall seeing that power of 2 to 53, and then we have separate power. If you're gonna go to here in constants, we have 2 constants, this and that, right? So notice that when we're storing 2 to the power of 64, you know, whole 64 bits, we're using big int. Otherwise, we're using the normal JavaScript number. What that suggests to me is that normal numbers in JavaScript are held by int64. Therefore, we can't go that high anymore. So int64 versus uint64. At least that's what I'm thinking. You're correct. JavaScript limitation. JavaScript regular numbers of type number can only safely represent integers up to 2 to the power of 53 minus 1. This is why big int is used for larger values. Okay, I see. Great. In nim implementation, absolutely right. You can just simply use uint64 for the tag values. There we go. So the tag is just simply uint64. and we'll be fine. So let's do that. Let's just straight up in our tag.nym say that this is a uint 64. Great. For some values could be less, but might be better to just leave it. Okay, I'll just add that note just so that we're aware. Okay, and uint64 everywhere so that we're 100% safe. Great, that we learned something, and I'm starting to understand what is going on here. Okay, makes sense. So we went through tagged. So I'm gonna take your advice, Taras, and I'm gonna take a peek at that section 3.1. So we've got introduction, objectives, terminology, CBOR data models, extended, specific, and specification of the CBOR encoding. Okay. So this will basically tell us about the encoding, while the other stuff will tell us about potential things that could happen. How long is this? Major types. Okay, so this is about the types. And we go all the way here, tagging of items. All right, and okay. It's a read, but we'll start, okay? We'll start, we'll see where it gets us to, all right? Oof. Okay. So a CBOR data item, section 2, is encoded to or decoded from a byte string carrying a well-formed encoded data item as described in this section. The encoding is summarized in Table 7 and Appendix B. Yay. That's why I don't read RFCs. It's just okay, reference here and there. I guess I'm better writing stuff like that than reading. Indexed by the initial byte. An encoder must produce only well-formed encoded data items. The decoder must not return a decoded data item when it encounters input that is not well-formed encoded CBOR data item. This does not detract from the usefulness of diagnostics and recovery tools, blah, blah, blah. Okay? Task says, so basically each subsection of section 3 is just implementation instructions for a single atomic implementation. So the initial byte of each recorded data item contains both information about the major type, the high order 3 bits, described in section 3.1, and additional information, the low order 5 bits, with a few exceptions. The additional information's value describes how to load an unsigned integer argument. Okay, so we have those 3 bits and the 5 bits, they amount to 8, right? With a few exceptions, the additional information's value describes how to load an unsigned. Oh, I see. So, okay. Less than 24. The argument's value is the value of the additional information. What? Less than 24, what does it mean? Those 5 bits are number lesser than 24? And 24, 5, 6, or 7. The argument's value is held in the following 1, 2, 4, or 8 bytes, respectively. Oh, I see. In the network byte order. For major type 7 and additional information value, these types are not used as an integer argument, but as floating point value. Okay, and major 7, I don't know. Okay, see section 3.3. I think I'm understanding. So basically those values here for the 5 bits are those 5 bits. how much data is that? Button. What's the largest integer or whatever? What is 2 to the power of 5? Gosh, I should have calculated that. 2 to the power 2, 4. I never remember those numbers. 16, 32. Okay, so it's 32. Okay, great. Why did I ask AI for that? This is stupid. So we got up to 32. So we're not using more? What if... Oh, 30. Oh, there we go. There we go. I'm thinking ahead. These values are reserved for future additions to the CBOR format. Okay, so it's data not used anymore. And 31, no argument value is derived. If the major type is 0, 1, or 6, the encoded item is not well formed. Oh no. For major types 2 to 5, the item's length is indefinite. Okay, okay, so this is basically saying it's indefinite. And for major type 7, the byte does not constitute a data item at all, but terminates an indefinite length item. All are described in section 3.2. Yeah, I recall reading that CBOR basically allows, indefinite length pieces of data. Taras says, I interpret it as if 5-bit value is less than 24, this means that there are no additional unsigned in following section and value of 5. What is that value? Okay. Yeah, exactly. So in other words, I'm understanding it pretty much the same. So the first 3 bits, they tell us what is the major type. And then we have the rest of them, those 5 bits. So these are the low order type, minor type, I guess. And basically because 5 bits allow us to describe a number from 0 to 31, we can say basically a little bit more. So if those 5 bits are a number less than 24, there's no extra data that describes the type itself, the type of data itself afterwards, after this byte that we're just reading, the initial byte. And then we've got something that suggests how many more bytes to read, because, they will represent the data. So, for example, for 27, it says that there's 8 bytes to load, and 8 bytes is an unsigned integer 64. So that's why those big shenanigans in JavaScript are because, JavaScript has trouble with large numbers. And for those, if we see those, that means it's just not right, because they are not used, those values. And 31 is basically used for type 2 and 5 to say that, hey, it's indefinite. And for type 7, the byte does not constitute a data item, but terminates an indefinite length item. All are described. Oh, okay, interesting. We'll see. Okay, we're getting some understanding to the code that we already wrote. The initial byte and any additional bytes consumed to construct the argument are collectively referred to as the head of the data item. Okay. The meaning of this argument depends on the major type. For example, in major type 0, the argument is the value of the data item itself. And in major type 1, the value of the data item is computed from the argument. In major type 2 and 3, it gives the length of the string data in bytes that follow. And in major types 4 and 5, it is used to determine the number of data items enclosed. Okay. If the encoded sequence of bytes ends before the end of the data item, that item is not well formed. Okay, so basically we can detect that there's a problem. If the encoded sequence of bytes still has bytes remaining after the outermost encoded or discarded is not a single well-formed CBOR item. Okay, depending on the application, the decoder may either treat the encoding as not well-formed or just identify the start of the remaining bytes to the application. And Tess says, this is the reason I said you should start with 3.1. We're nearly there. But, you know, things are starting to make sense. A CBOR decoder implementation can be based on a jump table with all 256 defined values for the initial byte. Table 7. Huh, interesting. Okay, I kind of like that idea. A decoder and a constraint implementation can instead use the structure of the initial byte and following bytes for more compact code. Okay, sure. So now we are at the at the section 3.1 that says I think 3.0 is just it just confuses. All right. So major types. The following lists the major types and additional information and other bytes associated with the type. Okay. Look up major types. So major types are the first 3 bits of a byte, of the first byte. So the following okay, so major type 0, an unsigned integer in a range of 0 to 2 to the power of 64. Minus 1, so a full UN64 inclusive. The value of the encoded item is the argument itself. For example, the integer 10 is denoted as 1 byte. Major type 0, additional information is 10. Oh. So wait, major type 0. An unsigned integer in the range of this. The value of the encoded item is the argument itself. So this is supposed to be the argument, right? How the hell am I supposed to get a range like that? For example, the integer 10 is denoted as the 1 byte. So this is number 10, right? 0. So we get 4. Wait, 4, this will be 8. What the heck? Major type 0, additional information is 10. The integer 500 would be what? Okay, I'm getting confused already. What on earth? I need to get back to basics with all this stuff, because this is starting to get confusing, okay? So let's get some kind of string here. Or I could probably just, let's do the separate the tabs. I'm just gonna get this one here on the side. Not this side, that side. And just close it all up. So the moment I see this value, right? 0b is binary, so we just have our bits. Those 3 say it's 0, so we can ignore that. And somehow this is supposed to be 10. So not sure right now if we're reading from left to right or from right to left. Let's assume it's from left to right or something, right? Test says if 5 bits is less than 24, they are the value. So that is why you can have integer 10 decoded as 1 byte. Oh, that's what you mean. Oh, I see. But if it's more than that, then we just have more bytes. I see. So we have basically 1, 2, 4, 8, and the last one is represented by representing 16. So we basically have 2 plus 8, which is 10. Okay, so that value makes sense. Great. So in the other one, we have this one. And additional information is 25. So 25 was representing that it will be additional 2 bytes. Okay. Okay, I see. All right, that makes sense. So we have basically 2 bytes to read, which in this case will contain that value. All right, that makes sense then. Thank you for pointing that out, Taras. It would take me way too long. I mean, I would decode value 25 and then probably figure out. But yeah, thanks for helping out. Okay, so here we know that this is for sure an integer. Unsigned integer, okay? Then we have major type 1, a negative integer. Okay, so basically a negative unsigned integer. Okay. That's a weird one. How the hell do I represent that in NIM? I guess I could create a type of negative then, right? That says, but if it's more than 23, then you would have more bytes. Now write decoder and encoder for major type 0 with tests. I could write without tests. AI can write tests for me. Okay, so that makes sense. And this is the negative one. Again, to negative 2 to 64th. Which I guess we could create, if we absolutely needed to describe that, a... what do you call it? Distinct integer that just represents those values. Because to... normally... you would just use a int as a signed integer, but that would mean that we need to have a 128-bit one. Probably not even that long one. No, we just need 1 extra bit to represent those values. So, I don't know. Who knows? Okay, but that makes sense. It's exactly the same as the other one. And has the -1. Okay. And then we've got major type 2, a byte string. The number of bytes in the string is equal to the argument. For example, a byte string whose length is 5 would have the initial byte of 5. Major type 2, additional information 5. Okay. Followed by 5 bytes of binary content. A byte string whose length is 500 would have 20. You have 3 initial bytes. Okay. Yeah, because 500 is already above value of a single byte, so we need 2 bytes for that. So we got the 25 for additional data and the 2 byte length to represent number 500, and then followed by the 500 bytes of content. Okay, that starts to make sense. It's very simple. Very, very, very simple. Awesome. So then we've got major type 3, a text string encoded as UTF-8. Okay. UTF-8, so that's awesome because I believe NIM is purely ASCII because you can encode UTF-8 with ASCII. So we probably wouldn't need to do much with that. The number of bytes in the string is equal to the argument. A string containing an invalid UTF-8 sequence is well formed but invalid. Okay, sure. We won't be verifying that for sure. We won't be. This type is provided for systems that need to interpret or display human readable text and allows for differentiation between unstructured bytes and text that has a specified repertoire, that of Unicode, and encoding UTF-8. In contrast to formats such as JSON, the Unicode characters in this type are never escaped. Exactly. That's a new line character. is always represented in a string as a byte, whatever, 13 or something, and never as byte this thing, the /n. Exactly, because we're already specifying the length of it, right? Okay, great. All right. This is actually helpful, Taras. Thank you. You convinced me. Major type 4. An array of data items. In other formats, arrays are also called lists, sequences, or tuples. A CBOR sequence is something slightly different, though. The argument is the number of data items in the array. Data items, okay? Items in an array do not need to all be of the same type. Okay. For example, an array that contains 10 items of any type would have an initial byte of this. Just we specified it's a type 4 and 10. Okay. Major type 4, additional information 10 for length. There we go. Followed by the 10 remaining items. And that doesn't specify how many bytes it is, because we're just expecting to go through the first bit of the next item, and we just have a counter that we count down as we process more items. So this is this sounds like something specifically designed to be what's the word here? R recursive. Okay. And Taras says, I'm glad you're enjoying it. Let's call it I'm enjoying it, okay? I'm enjoying that it's explained not in a worst possible language. Major type 5, a map of pairs of data items. Okay, maps are also called tables, dictionaries, hashes, or objects in JSON. A map is comprised of pairs of data items, each pair consisting of a key that is immediately followed by a value. The argument is the number of pairs of data items in the map. Okay, for example, a map that contains 9 pairs would have the initial byte of 5, major type 5, and additional information 9 for the number of pairs. There we go. Followed by the 18 remaining items. Okay, so that already, if we have the 18 remaining items, that already suggests that keys could be whatever value there is. The first item is the first key, the second item is the first value, third item, second key, and so on. Because items in a map come in pairs, their total number is always even. A map that contains an odd number of items, no value data present after the last key data item, is not well formed. There we go. A map that has duplicate keys may be well formed, but it is not valid. And thus it causes indeterminate decoding. Okay. So this straight up doesn't suggest what if there's a differentiation, you know, like, okay, the key needs to be a different, some specific subset of types, but no, it just says do whatever you want. Put another map as your key. Okay. I see. I just don't like that idea for dealing with that data, but we'll see how that goes. The good thing is that our use case, SurrealDB, has some of its own limitations. Therefore, I will be still following the document, the implementation from the JavaScript framework, whatever, the JavaScript SDK. But it will be easier to follow it thanks to this explanation here. And that will probably have just, you know, only the necessary parts implemented rather than going for everything. Major type 6, a tagged data item, tag, whose tag number, an integer in the range of 0 to 264 minus 1. Inclusive is the argument whose tag number, okay, in the range of this inclusive is an argument and whose enclosed data item, tag content, is the single encoded data item that follows the head. Okay, so understand it that those tags is basically tag number. It can be from 0 to 2 to the power of 64. That is a lot of tags to implement. Holy macaroni. So What that means is that we can probably enclose that tag number if the number is less than 24. If it's more, we just specify how many bytes, right? Okay, that makes sense. That's already implied in this case. Is the argument, and whose enclosed data item, the tag content, is the single encoded data item. Okay, the content, which will be the value in this case. Okay. Major type 7, floating point numbers and simple values, as well as the break stop code. Ooh, okay. So that'll be a separate section for the combination of those weird things. These 8 major types lead to a simple table showing which of the 256 possible values for the initial byte of a data item are used. Okay. In major types 6 and 7, many of the possible values are preserved for future specification. Okay. See section 9 for more information on these values. Okay. And table 1 summarizes the major types defined in CBOR, ignoring section 3.2 for now. Okay, so unsigned integer and negative integer byte string. Okay, for the content. Text string. Okay, how many bytes? And then we have array, map, tag number, and simple / float. Okay, that's great. So I can already see that 3.2 is indefinite lengths for some major types. I will read that because I know that this is being used for sure in SurrealDB. At least that's what I'm expecting. It will be good to know because this probably changes how some things might work. So 3.2, indefinite length for some major types. For CBOR items, arrays, maps, byte strings, and text strings can be encoded with an indefinite length using additional information value 31. This is useful for the encoding of the item. This is useful if the encoding of the item needs to begin before the number of items inside the array or map or the total length of the string is known. The ability to start sending data item before all of it is known is often referred to as streaming within that data item. Great, that makes sense. And I would presume that that's what SurrealDB is using so that we can actually start sending data ASAP. Indefinite length arrays and maps are dealt with differently than indefinite length strings, byte strings, and text strings. Okay, so we have the break stop code. The break stop code is encoded with major type 7 and additional information, value 31. Okay, so that will be the major 7, value 31. So it's just a bunch of ones. There we go. It is not itself a data item. It is just a syntactic feature to close an indefinite length item. So the thing that I'm already expecting before I read later, I'm already suspecting that the way it's gonna work is we're gonna have probably one byte that says how many next items, how many next bytes are representing some value to the code. Okay. And we're gonna read it. Okay. After which we're expecting another, number of bytes that we are supposed to read, or that stop code. And this way we can just read things in small little chunks and until we basically find out break code. So that's how I would probably naively interpret it, but it might be easy enough, right? If the break stop code appears where a data item is expected, other than directly inside an indefinite length string, array, or map, for example, directly inside the definite length array or map, the enclosing item is not well formed. Where a data item is expected, other than directly inside the indefinite length string array. Okay, yeah, makes sense. So only when we're expecting it, it makes sense. So arrays and maps. Indefinite length arrays and maps are represented using their major type with the additional information, value of 31, followed by an arbitrary length sequence of 0 or more items for an array or key value pairs for a map, followed by the break stop code. In other words, indefinite length arrays and map look identical to other arrays and maps except for being with the additional information value of 31 and ending with the break stop code. Okay, so basically we assume that instead of getting a specific size of the array, like those first bytes or whatever, I mean those 5 bits telling us what the length is, if they are set to 31, that means that okay, this is going to be indefinite, and therefore don't bother with the counter, just keep going until at some point the next next first byte of the next item is basically the 31. I mean just a bunch of ones. Okay. If the break stop code appears after a key in a map in place of that key's value, the map is not well formed. Okay. There's no restriction against nesting indefinite length arrays or map items. A break only terminates a single item, so nested indefinite length items need exactly as many break stop codes as the type bytes starting an indefinite length item. Makes sense. So this is again just so that we can process it recursively easily. For example, assume an encoder wants to represent the abstract array. This thing, right? The definite length encoding would be blah. That's fun. So array of length 3. Bam. Array of length 2. Bam, bam. And that. Indefinite length encoding could be applied independently to each of the 3 arrays encoded in this data item as required, leading to representations such as, start indefinite length array. The F here is the result of having just a bunch of ones at the end. And we say, okay, this is the first item, and it's number 1. So that basically says, okay, we have an array of 1, right? And then we go array of length 2. Wait, what is this 1 for? Oh, that's our value 1, right? Because it's 0, 1 to specify that it's a integer, something like that. Yeah. And then we've got array of length 2. There we go. And we've got those 2. Oh, okay. And then we start indefinite length array. So again, we have the values until we find a break. And we just broke out of this one. And this is break for the main one. Okay, exactly. That makes sense. And here's a different option for it. Yep. And just summon a variance. That happens to have 2 key value pairs might be. Okay. So we have length map. First key. Bam. And we've got the value. Then first value true. Bam. Bam. Until, so we've got the first pair. We've got a second pair. And the break. Okay, makes sense. Simple enough. Okay. So let's continue the indefinite length byte strings and text strings. So this is probably gonna be, with those lines. Indefinite length strings are represented by a byte containing the major type for byte strings or text string with additional information value of 31 followed by a series of 0 or more strings of the specified type. Chunks, there we go, that have definite lengths. And finished by the break stop code. There we go. The data item represented by the indefinite length string is the concatenation of the chunks. If no chunks are present, the data item is an empty string of the specified type. 0 length chunks, while not particularly useful, are permitted. Yep. 0 length chunks could be something like, hey, keep the connection, right? Okay. Something like a ping, like this is still going. Okay. If an item between the indefinite length string indicator and the break stop code is not a definite length string item of the string is not well formed. Of course. So design does not allow nesting indefinite length strings as chunks into indefinite length strings. I mean, that wouldn't make any sense. So, yeah, if they were allowed, it would require the coder implementations to keep a stack or at least a count of nesting levels. Yeah, because all this stuff, like while I'm saying it could be recursive, you could make it some kind of, I guess, linear if you want to. Okay, that makes sense. If an indefinite length text is invalid, of course. Note that this implies that the UTF-8 bytes of single Unicode point cannot be spread between chunks. In theory, but you could go in naive way and just go for it. Okay, so that's simple, right? So start indefinite length this thing, and we just say byte string of length 4. Yeah, and we just give it 4 numbers of like 3. There we go, and there we go break. There we go. Okay, so we just send it as byte strings. Huh. Okay. Summary of indefinite length use of major types. So for 0, of course, and 1, it doesn't matter. It doesn't make sense. Byte string is number 2. Definite length. Wait, 4 is array. What? Start indefinite length byte string. I mean, yeah, of course, it doesn't have the number 4 here because it doesn't make sense. It's just we're saying it's a byte string. Okay. Well, this is okay, byte string. Oh, okay. So we just keep going with the same stuff. Okay, makes sense. So we've got those two. It's fine. Arrays and maps we know. And number 6 does support that because it was something else. And oh, that was a tag. And number 7 was floats or something, which again are some other simple stuff. So let's just finish off with floating point numbers so that we have an idea of what the hell's going on, because it's not just floating point numbers, it's also values with no content. Oh, I see. So major type 7 is for 2 types of data, floating point numbers and simple values that do not need any content. So I guess they all fit in an argument, right? Each value of the 5-bit additional information in the initial byte has its own separate meaning, as defined in table 3. Like the major types for integers, items of this major type do not carry content data. All the information is in the initial bytes. So basically we have type 7. For 0 to 23 we have simple value. So value from 0 to 23. Okay. And 24 is a simple value. Value from 32 to 255 and following byte. Okay. So just a simple byte. And then we got 25. Half precision float, 16 bits. Okay, that follow. Then we got single precision float and double precision float. Okay. And then 28, 30 are reserved. And 31 is, of course, a break. So what the hell is up with those? Because I guess in theory that's different, but maybe we have specified the specific values, right? For those, because we already have something that can represent this as a number, actually both of them as an integer. So what the heck? As with all other major types, the 5-bit value 24 signifies a single byte extension. It is followed by an additional byte. Okay. This maintains the structure of the initial bytes for the other major types. The length of these always depend on the additional information in the first byte. Yep. And available for simple values. Okay, so from 0 to 19 is straight up unassigned. We just don't have anything for that yet. And then we've got 20 for false, 21 for true, 22 for null, and 23 for undefined. Look at that. So we can kind of consider that to be none in SurrealDB. Huh, interesting. And 24, 31, of course, are reserved for different purposes. And 32 to 255. What do you mean? Assign and variable for simple values. You mean the next byte? Okay, I'm getting confused again. Because this is just major num type 7. So first 3 bits are already taken care of. What the hell's up with that? An encoder must not issue 2-byte sequences that start with major type 7 additional information 24. So the 24 value from 32 to 255 in the following byte. Oh, okay. So basically, if we go in a whatever, first 3 bits are number 7 because that's its type. But then we have those 5 values that specify this value here, right? So from 0 to 23, we have that value, and these are those specific ones here. And then if this was 24, then we get this additional value. That could be something else, but they are all unassigned as well. So an encoder must not issue 2-byte sequences that start with 0, major type 7 additional information 24, and continue with a byte less than 32 decimal. Okay, so that's the thing. It wouldn't make any sense, because either it's using, the values here, or if it's larger, then goes to here. So if we have suddenly a number smaller here, points at those, it means that, that somebody who was writing this code didn't know what I mean. So I guess that makes some kind of sense. Okay. Displays encoder cannot encode false, true, null, or undefined in 2-byte sequences. Yep. So it's just basically only one way to represent that specific value. So the 5-bit values of 25, 26, and 27 are for 16, 32, and 64-bit floating point values. These floating point values are encoded in the additional bytes of the appropriate size. And then we have the last one, which is the tagging of items. I think we're just gonna go through that quickly. Holy macaroni, there's just so much more. Woo! But the whole idea is that in CBOR, a data item can be enclosed by a tag. To give it some additional semantics, is uniquely identified by a tag number. The tag is major type 6. Its argument indicates the tag number, and it contains a single enclosed data item. The tag content. Okay. If a tag requires further structure to its content, the structure is provided by the enclosed data item. There we go. We use the term tag for the entire data item consisting of both a tag number and a tag content. The tag content is the data item that is being tagged. There we go. For example, assume that a byte string of length 12 is marked with a tag of number 2 to indicate it is an unsigned big number. Okay? The encoded data item would start with a byte. So we've got the number 6, major type 6, additional information 2, because that's the number of the tag. Okay. Followed by the encoded tag content, which is major type 2, additional information for the 12, additional information 12 for the length. Okay, so this specifies the format that we're gonna follow, but we already have a tag that You know what? This is number 2, so we have this additional number that specified that. Oh, okay. We know how to interpret that byte array or whatever. Okay, that makes sense. All right. I see. So it doesn't specify the structure itself, it just gives that extra number to specify, okay, it's of this type or some other type or whatnot. All right, makes sense. And am I breaking up or something? Yeah, it shows that I'm dropping frames, which is like, what the hell? I guess something is happening to the internet again. Sorry about that. I hope at least my audio is okay. There you go, Xfinity. Yep, lag. Sorry about that, Taras, and everyone else. Like I said, I hope at least audio is somewhat hearable. Ay, ay, ay. Oh, last time it fixed itself at some point, right? Yeah, it shows like I'm dropping half the frames or something. Okay, numbers are getting back to normal. Hopefully it's gonna stay that way. I don't know. Sorry about that. So I'm gonna just continue, just to not sit and do nothing, right? Okay, so we went through that. That was fine. In the extended generic data model, a tag number's definition describes the additional semantic conveyed with the tag number. These semantics may include equivalence of some tag data items with other data items, including some that can be represented in the basic generic data model. For instance, this is a big number, big num, and the tag content of which is the byte string with a single byte is equivalent of an integer 1. Okay. The tag definition usually defines which nested data items are valid for such tags. Usually. Tag definitions may restrict their content to a very specific syntactic structure, as the tags defined in this document do. Or they may define their content more semantically. An example for the latter of how tags 40 and 1040 accept multiple ways to represent arrays. Okay. As a matter of convention, many tags do not accept null or undefined values as tag content. Instead, the expectation is that a null or undefined value can be used in place of the entire tag. Okay, makes sense. So this will be very specific to to SurrealDB. So I think we're gonna stop reading through the documentation right now because we have data items like text string, integer, float, byte string, array, any, just depending on what encoding, byte string, various kinds of text strings, and self-described CBOR. So you can send CBOR in CBOR or something? I guess it's possible, right? Okay, that makes sense. So we're gonna go to CBOR page on SurrealDB documentation, right? CBOR protocol. You can see that Surreal supports the CBOR protocol shipped with an additional couple of custom tags. So we have the official tags, which is by IANA, enter assigned numbers authority. And that there's lots of tags, and I don't think we'll be implementing all of them because it wouldn't make sense in this case. But we have tag 0 for date times, none, table name, record ID, UID, all that stuff. Just some of them. And we have even more details, like tag number 6 represents a non-value. The value passed to the tag value is null, as it cannot be empty. Okay, yeah, we just need to set some value to it. I'm surprised that SurrealDB didn't go with, hey, just send me an undefined, but I guess it makes sense. A table name representing a string, all the stuff, a record ID represented as a 2-value array containing a table part, string, and ID part, which is string, number, object, or array. Instead of a 2-value array, SurrealDB also accepts a string with a string formatted record ID. A string record ID will never be sent back from SurrealDB, however. Okay, so SurrealDB will process it and send back normal stuff. Okay, makes sense. Oh, and your IDs have 2 values, either as represented as string format or as binary format. Okay, I see. Okay, I'm starting to have some kind of idea how this protocol works, and it's actually like dead simple. So yeah, thank you, Taras, for recommending actually looking at that, because it clarified a lot of my questions, and I know that at this point I will be somewhat ready to just write it from scratch or something. But I will not attempt that. We'll just follow the we'll just follow the TypeScript implementation and modify it with the power of nym, where we can have just a little bit more control over the stuff, over the data representation, just like here. Okay. So in that case, if we're gonna look at the gap, do we get more information about the gap this way? Because first of all, we have, wait, I have nym here and TypeScript here. That's the wrong way around. We'll make the TypeScript a little smaller. There we go. So basically for gap, and in TypeScript says, why is the default value being stored in an array? Undefined, null, false, etc. are all valid defaults. And specifying a field on a class as optional will make it undefined by default. Okay. So yeah, why to specify it as an array, right? Don't know. So basically, a gap is, in our case, a placeholder for already encoded CBOR data. Or as in, hey, this can store some data. Why the hell would we use that? I'm not sure. Why would we be using a partially encoded data? Unless we have... Oh, I see. Oh, I think why. I think I know why, because we could kind of predefine some data already kind of structured like CBOR, and then just add in some data in the middle. Like, hey, maybe we have, well, maybe we already made a packet that has this specific ID as a request and a few other things. And then we just reuse this package and just fill that gap and something else whenever we need to. And Taras says, in my opinion, TypeScript might not be the best implementation. Maybe try to roll your own and then compare. I'll think about it. I think we're gonna just go through the TypeScript implementation first to see if we can kind of comprehend what's going on, because it's not that simple at the same time. Because we have, the constants here are simple. We have the major type, right? That's fine from 0 to 7. And we learned that those powers are just specifically to figure out how to store the numbers in a JavaScript way, which is just, you know, the necessity with JavaScript. That's its quirk. No idea what a replacer is. It's just some kind of function that takes an unknown value and returns a different unknown value. I guess, okay, this is, you know, a shape of a function that would just replace something with something. So, yeah. And that says usually it would be easier to start from basics, type by type. Yeah. I just want to go through that quickly. And then I'll make a decision. So that was fine. So if we're gonna do, let's say we want to encode something, right? So let's take a peek at, I mean, we have index that just imports everything. So let's look at encoder, okay? So encoder, basically, we have encoder options, which is, you know, maybe specify a replacer for some reason. Am I dropping again? Yeah, I'm dropping again. Sorry. Don't know what the hell's going on with the internet. It's very strange. So what on earth was I doing? Encoder options, so replacer, writer, partial, and fills. Okay. Very interesting. Why do we set all of those? Writer, understand, because we're encoding. This is some place where we're writing. Could be many things, right? Could be writing to a stream that we're sending to through HTTP or something, or through WebSockets, or who knows. Partial and fills. So then we have the encode. Oh, I wonder if... Oh, I think I know. So we can have a template that has gaps in it created, and we can create separate fills by providing those specific gaps. And therefore, as we're processing, we encounter like, oh, this is a gap here. Let's see if we receive something to fill it with and find it and just replace it that way. Interesting. I see. So then we have the encode itself, that it gets some kind of takes some kind of input and the options. And it can return either a partial or just an array buffer. Okay. So we basically get our writer. We create a map of fills. Okay. And then we have the inner function that we'll get to in a second. That just takes some kind of input. So what we're doing, we're just saying, you know, take that input and call inner on it. Okay. So basically encode it. And then at the end, we just take the output of the writer that we were using probably inside the inner, and either as partial or something. Okay. So that's that. And then I guess we have a chance to replace something with something. So the inner is what actually takes the data and turns it into CBOR. So what are we doing here? So basically our constant value is the replacer. If replacer is set, we replace the input with whatever this thing does, input. So we have no clue what replacer is used for at this point. Interesting. We'll ignore that. It's just, you know, at the end, we just get a value. So here we're doing those things. If it's undefined, we just write the byte. That F7, I guess, is already predefined that this is our, what do you call it? The undefined. The same with null, with true, because these are all those type 7, I don't know, 20 or something, etc. The same with true and false, so we can just take care of them immediately. Okay? So I guess we'll need to... Okay, I'm starting forming an idea of how to be able to pass this data to nym, because this will involve dynamic figuring out what the hell this tab is, what the hell that tab is of some kind of structured data. So that's interesting. And then we have basically, if it was none of those, then we call the type of value because we need to check them differently in JavaScript. So if it's a number, then we have the shenanigans. Should we, if it's larger than 0, it's the positive one. If it's less than 0, we need to make it negative. Otherwise, and depending if it's those powers or not, blah, blah, blah. Otherwise, it's just, sorry, we just can't encode this number with CBOR, okay? Yeah. And that's for if it's integer. Otherwise, we just save it as float. Okay. So I guess on nym side, we'll need to actually take care of all the various sizes of integer. I'm not sure how I'm gonna bite it yet. How I'm gonna approach it yet. And then we've got the big integers, and again, that's some other stuff. Because that's suddenly power of 64. 64-bit integers. So we won't have this distinction. Then we have strings, and here we're basically major 3. Okay, so we just do that. Encoded byte length. Okay, so we have text encoder encode the value. Okay, we encode the value of the string first, and we just straight up, hey, this is that. We have it as encode. Okay, makes sense. Taras says, you see, they badly implement and they fail to compact integers. Yeah, could be done, although something tells me with JavaScript, it's just faster to let it just convert into that large number. Because if you have a bunch of if-elses in JavaScript, it means you need to run a lot more code, and those if-elses could actually take up more CPU time than the actual encoding to a larger number. Yeah, or depending how the writer is implemented, yeah. But here, write major, 0, 1, and value. If this, write major, 0 and a value. Length, number, or big int. What the heck? Don't know. They saved numbers somehow. No need to dwell on it. So if a case string, we did that. And otherwise, we need to check for things in yet different ways in JavaScript, because it's JavaScript. There's a million ways to check for various types. So if it's an array, we just say that it's an array, how many elements in that array, and we basically recursively do stuff inside of it. And that's it. That makes sense. If it's instead of tagged, so we know already that it's a tag, then we're just gonna make a tag and just run whatever inside. Makes sense. And then we've got encoded, which is already that we already have something. So we just write the array buffer and that's it. Just plop it in there. If it's a gap, if it has the value. Wait. Oh, so if we encounter a gap, we check if we have the gap provided as a fill, right? We check that and we basically say, hey, encode that value of whatever we provided to fill the gap with. Otherwise, options partial, throw this one. Nope. Oh, so if it's not partial, we are upset that we got a gap without implementation, and we say, sorry, we can't do that. Otherwise, just write the value, which is the default thing, I guess. Interesting. So Taras says, but CBOR is about compact representation. Yes, it is. And it's already way more compact than Java, than JSON. So here is, I guess it's taken as a win-win. And also the thing is that SurrealDB itself doesn't have a way to specify the size of an integer. In SurrealDB, as a database, stores numbers in 3 possible types. Number, which is either an integer or a float. Then you have integer or float. And that's it. You don't have those distinctions. So however you send the integer value, it doesn't matter. I presume in the case of JavaScript, it's just faster, therefore more efficient, performant to... You got a value, just serialize it in one form, because running additional checks, you know, this is an interpreted language, means that there's more of content to interpret, therefore you're dealing with strings or some other stuff, and it just becomes slower at the end than actually performing just one operation, even though it's not the most optimized one. So potentially, although I don't think this was actually tested. Maybe it was, but I don't think so. I don't think it matters that much. I believe this code was just written so that there's something working. And you can use CBOR with the database and continue on, be testing, and will be refined in probably nearest future, I'd expect. So we've got the gap replacement. So I really like that idea of those fills and gaps. So that's something I would like to be able to support. And then we've got the partially encoded, partially. So we have some other shenanigans with encoding some partial stuff. And we pass, I guess, more stuff to it. Value build. Okay, so if it's a partial, then we have some kind of method to build that partial by providing with more fills and encode it. So I guess... Interesting. So I guess we can just nest partially encoded stuff inside to reuse chunks of data that are often reused throughout the database. You know, because some things will be just repeated non-stop over and over, so we can encode them once, call it partial, and just pass it by around as, you know, put the same thing here, put the same thing there, put the same thing there. It just has few gaps of which parts of it only to replace. So that's a neat little system. I like that. And then if we provided some specific arrays, we just need to write them as byte arrays. Okay. Because this is purely to support that, you know, it's a JavaScript SDK. User might want to encode various types of things. So that's that. So that was that. And otherwise, entries, value instance of map. Oh, and then basically we have the map. And we don't have any other ifs. So at the end, the worst case scenario, just it's an object, some kind of map. Do that. Okay, makes sense. And it's just recursive like that. Hey, that's simple. The thing is that we can't even test that without a decoder, because the moment we establish connection with the database as CBOR, we'll be getting CBOR, all the data in form of CBOR, and we'll be sending in CBOR. So we need both encoder and decoder. And I think decoder will be very similar, right? We'll just read the other way around. So decode, we just give it array buffer or a reader. Some decoding options like, is it an object, is it a map and replacer? Okay. And we have the same inner function and decode. And we just run decode from inside of a decode. What? Biome, ignore. Lint, suspicious, no explicit and any. Don't know what it will return. Yeah. Yeah, because we don't know what this thing is gonna return. Huh. So... yeah. But I never seen function decode with a sub-function decode. It's kind of silly. An inner would be basically, okay, let's... okay, so we have a reader allows us to split the major and the arguments, right? And the major is that, do that, 1, 2, 3, 4, and we have 5, 6, and 7, right? And depending on that, we're doing things. So 7 will know that it's a false, true, null, undefined, or whatnot. So now, the thing in Java is that JavaScript has one nice thing about it. We are able to just give it some data, and it's happy about it. But with NIM, I would basically need to implement specific functions, specific procedures for specific types of values. Because specific for Boolean, specific for other things, which means that from performance perspective, it's going to be way faster because already during compilation time, we know what kind of data are we dealing with. But then the thing is that we would need to be also able to, I want to serialize, send to the database this custom type or something. So I guess we're entering realm of marshalling, which I'm not happy about because I have absolutely no idea how that works. And the only reason I actually know the word marshalling is because I already looked at a few things, scratching my head. How the hell do I provide custom type to their type T and I extract the values out of it? So how the heck is that supposed to work? So let's look at NimDocs, okay? We're gonna go to standard library, and here we can find JSON, because JSON is supposed to already implement that, right? Because we can call, as something like JSON something. There we go, unmarshalling. In addition to reading dynamic data, Nim can also unmarshal JSON directly into a type with the to macro. So this is in that direction, okay? Note, use option for keys sometimes missing in JSON responses and backticks around keys with a reserved keyword as name. So in this case, we can say to username. So user is that user JSON, and we want it as a type user. And it magically figures out how to put it together. But can we do the other way around? Because here we're parsing into nim JSON nodes, a JSON node from which we can extract that. And if user type is some, user type get, it's not robot. Oh, because it has that thing. Okay. Yeah. But what about the other way around? Do I need to, on my own type, do I need to specify how to actually serialize it by myself? Because we have reading values, parsing JSON. I don't want to parse it. I want to make JSON. Okay. Parse, 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 parse. Creating JSON. Can also use to comfortably create JSON using the %* operator. Okay. And Taras says, let's maybe just have writer and reader first. Yes, we will. I just want to make sure that I'm understanding how this thing is gonna work eventually, you know, in the NIM format. Because there are just so many unknowns that I don't know about the NIM language yet, haven't done yet. So I'm not sure how to handle it. Okay, so we can examples of creating JSON, right? We have this and that, and JSON, we just, hey, serialize all that, right? This is fine. These are all just bits of simple data. Hookable JSON serialization searches of arbitrary types. Okay, so that's fine. But how do I guess I would need to define my own thing? I guess so. Okay. But let's just see how this unmarshalling goes, because what is the to? What does the to do? Unmarshalling the to macro. So macros, we have this one and this one. We don't have the to macro in here. What the hell? To. There we go. Unmarshals a specified node into the object type specified. No limitations. Heterogeneous arrays are not supported. Sets and object variants are not supported. Not null annotations are not supported. So parse JSON like this. And we have the type and two types. Say data to JSON node data. Okay, so we unmarshal that. How is that implemented? We've got the examples, that's fine. Oh. Then we have when false. So basically never. Oh, wait a moment. Is that it? Proc. We want something with this kind of indentation. So runnable examples here. And this is the thing. var JSON path is that result default of type T init from JSON. Oh dear. Oh dear. This does not make me happy. I think we're gonna need to create at some point basically our equivalent of a JSON node. A format that can hold various kinds of data in a structured way, and then initially provide a way to format your type, you know, provide an operator for your type to export itself in that fashion, you know, in a SurrealDB specific fashion, how you want to store the data. And then we will need to have the reverse process that we can probably specify to make it manual initially, and then make it the other way around, you know, add marshalling in the future, or unmarshalling or whatever, maybe both at some point, when I'll be able to understand it, because it's just, you know, like layers are stacking on top of complexity on top of each other right now, and because this is my first try at something of that sort, it's not the greatest position to be in. Okay, so we know how to decode and encode roughly. That's gonna be relatively easy part, I believe. But then, like Taras said, we need to look at what a writer and reader are doing. So let's just take a peek at writer, what it's even doing, how it's handling it. It's not a lot of code, okay? So a writer has basically chunks of, array buffer and a gap. Okay, I see. We have position. We have some kind of buffer, a data view, whatever that is, and a byte that we're operating on, I guess, which is a uint8 array. Huh, that's a byte. So we have constructor. We have default value of byte length to be 256. And okay, the buffer of that many. Okay. We create some kind of view to the buffer, and we have the byte as. Do we have it defined somewhere? Okay, ES2022 returns an item located at the specified index. Okay, so this is basically a way to look at a byte inside an array. Okay, and what is data view? Is who the hell knows what? Okay, so doesn't matter, we need to understand everything. We can get chunks and just returns that, the same with the buffer, where we say from 0 to this position. So, okay, so buffer is some kind of buffer, and as we're writing into it, it fills up, and we track that position to where we filled it up, and then we can probably flush the buffer, actually write it and whatnot. So, you know, a somewhat normal situation. And those chunks are probably those buffers that we had so far. And then we have claim. We'll get to that in a second. And then we have a bunch of ways to basically write various length uintegers. Arrays, write array buffers and partially encoded floats. And then the thing where we can specify the major and the argument. Okay. And depending on those lengths, it automatically knows how many how many bytes to write and whatnot. Okay, that makes sense. And then we have the output that can be partial. And some replacers. So what does that replacer do? Return partially encoded. So if it's partial, return partially encoded. This chunks, this buffer, and replacer is partial. Okay, otherwise, return this buffer. This is confusing, but I presume we just... Because the chunks are tuples. So chunks is basically an array of tuples of array buffer, some kind of data, and a gap. What the hell is the gap for here? Do we use those chunks somewhere? We have this, and here, and here. Holy macaroni, this is confusing as hell. I'm just gonna ask AI to explain how it works. So let's just create a new conversation. Please explain how the writer works. I'm confused by all the chunks, data views, partials, and whatever was their claims. I just indicated AI that we're really confused. So initialization. Buff is the underlying array buffer. Data view for easy manipulation of the buffer. Okay, so data view is for manipulation and is byte level operations. Okay, interesting. And hello, Fabio. Hexcondi, how many video parts until the driver becomes usable? If you can give us an educated guess. And congrats for all the hard work. Thank you. When? In theory, in theory, you can use it. Let me roughly show you what I mean. So in theory, if you don't mind dealing with JSON, you can use it. Because if I'm gonna go to Surreal, it has some kind of basic example. Because you can create a new SurrealDB connection. Oh, right. It's usable, it's just not exported as an actual package on as a Nimble package. I need to figure that out. I just didn't realize that that's even there yet. But if you don't mind quickly copying the code, it can be usable. I would like to, maybe I'll make it in a current state available as a package. I just need to probably this weekend to figure out how to actually structure a package to be properly published. But when published, you'll be able to just create a new SurrealDB connection, right? All you need to have is the library and the async dispatch, and just dealing with features and JSON, and that will be basically it. And then you can normally call use with namespace and database to switch to that. You can sign in various ways. It's already supported. Don't know if record users are working, but in theory they should. And then what basically happens is that you can normally create things, you can normally select things, you can make record and give it a string, you can make, whole objects and whatnot. The only thing is that when, for example, you select, what you're getting as a response is a Surreal response. So if we're gonna go to types, you get a Surreal result. That's the thing. A Surreal result, which is basically a result that holds either the type, which in this case will be just a JSON node, or Surreal error. And so what you can do is, where did it go now? So basically you can say, hey, this is my response. If it's okay, you have the .ok available, and this will be a JSON node. If not, you have error available, and that will be just an error. And this way you can basically handle everything, and you're just gonna get JSON nodes that you can do with whatever you want. So in theory it's usable because it connects to the database, and we have most of the queries implemented. If I'm gonna go to queries, we have all of those implemented. The only thing that's not implemented is live queries, because they will need some additional subsystem. And we don't have the JSON patch or sending GraphQL queries or query raw, because they're all kind of raw already. So yeah, for testing it works, but I wouldn't say that it's production ready, because it's gonna be changing after we implement the CBOR protocol to make it, to avoid the whole JSON shenanigans. So that's that. But I'll try this weekend to export it as, to publish it as an actual package that you can use on Nimble. It's just I have never done that, and I don't like dealing with Nimble, to be honest, because it's very unintuitive. Like, how on earth do you structure it? But I'll get through that, and I'm gonna let you know. All right, I'm gonna send you a DM when I did that. Okay, so I was just trying to understand the writer, right? The chunks and partials. The chunks array is used to import partial encoding. Support part. Each chunk is a tuple of array buffer and a gap. An array buffer is basically, a buffer. This allows the writer to handle gaps in the data, which can be filled later. Okay, I see. So writing data, the writer has method to write various data types. Okay, these methods use the data view to set values at specific positions in the buffer. Okay. Claim. The claim method is crucial for managing buffer space. When writing data, it checks if there's enough space in the current buffer. Okay, when writing. Okay. If not, it doubles the buffer size until it's large enough, returns the position where the new data should be written. Okay, so the buffer can grow. I see. In partial encoding, the chunk method supports partial encoding by saving the current buffer content and a gap. Resetting the buffer for you to... Oh, so basically, if you want to have gaps, you basically make several chunks of your buffer and insert gaps in between. So a chunk, it's as a tuple because it's either array buffer or a gap. So that's interesting. Huh. Now output, the output method finalizes the writing process for partial encoding and returns partial encoded object, which with all chunks in the final buffer. And for complete encoding, it returns the final buffer. Okay, I see what's going on. So in case of it not having gaps, it's just one buffer, so it doesn't matter. I see. Fiber says, great and thanks. Yep, it's a fun project so far. I'm enjoying it, combining the two, learning a lot of NIM. And you probably saw me asking some somewhat related questions on the NIM Discord. Okay, so the complexity comes from balancing efficiency using a growing buffer with flexibility, supporting partial encoding and gaps. The data view and uint array provide efficient ways to manipulate the buffer at different levels of granularity. This design allows the writer to handle both simple, complete writes and more complex scenarios where parts of the data might be missing or filled in later, which is useful for the CBOR encoding process in the context of SurrealDB RPC mechanisms. Okay, so I can see that we can actually feed it. Where was it? So at some point we have write partial, right? Write partially encoded. So that will probably go over the data chunks of that partially encoded and combine them. Oh, I see. Okay, I think I know what's behind the scenes. I just don't know how to explain it. But it basically combines the outer chunks with the existing ones here and just inputs the other stuff. Okay, that makes sense. Absolutely. Cool. And this chunk gap. So the chunk will probably... okay. Wait, get chunks? Chunk, there we go. So it adds the current buffer as a new chunk, resets the buffer, resets the view and bytes so that because we just reset the buffer, they all need to point to position 0. Okay, so that makes sense. Okay, I'm starting to get a grasp of how the writer is working. So that's great. Okay. I totally don't mind that. And how about reader? Reader would be probably way simpler, right? Or not. So we have the same concept, buffer, view, and byte. We just don't deal with chunks. Because if we have a reader, that means we don't need to support partials, right? Because we already got the whole thing. Okay. So constructor, we just say array buffer like. Okay, whatever that is. So it's either array buffer or shared array buffer. Okay. And we just say create a new buffer for it. And reset those things, right? And then we have read. We say how much and result t. Return. Huh? Okay, that's some private stuff. So, we just quickly move it forward, that's it. So we can read the uint. Okay. I see. And basically 1 byte, read 2 bytes as a number, this and that. We have basically operations for those basic ones. And then for, yeah, so this is basically for all the major types that CBOR supports, right? And then we got the read major, which is basically read the byte and extract the major, and then the rest as the argument. Okay, somehow. And length is, oh, basically if it's less, then we specify the number. Otherwise, we grab other stuff. So read major length, it's kind of a weird name. It should be read the argument, or yeah, I guess the argument. Huh. Length. What a weird name for that. Okay, so this just basically allows us to give it all the, the array buffer, all the data that we received, and just different operations to read through it, and each read just advances the cursor or whatever forward a little bit, right? The byte at which we're looking, position. There we go. Just advances it a little bit forward every time, so that we don't read the same thing multiple times. Okay. That is very simple. And I wonder if we should start from the reader actually. And yeah, maybe we'll start from the reader. It's just how the heck do we deal with those arrays now? in a somewhat fast way. I think we're just gonna start with the what do you call them? We'll just start with byte sequences. And when we have it implemented in that way, we can start to look for ways to improve it a little bit further. And why do we have problems with internet again? What is going on? Yeah. Sorry that I'm so choppy. Okay. So let's make it a reader. Okay. We start with this tag, then whatnot. Well, I'm gonna leave it for now. I'm just create new file, reader.nym. Okay. So we're just gonna make it a reference object. Okay. So type reader. Okay. Let's make it a CBOR reader. Okay. CBOR reader is ref object. So yeah, a reader of CBOR data. Of a reader for raw CBOR data bytes. Okay, byte array, something of that sort. So what we want here is we want to store the data as some kind of sequence of bytes. Okay, that will be our data, and then the position at which we're reading, and I think that's good enough for now. So we don't want to expose those values at all. Once we create it, it just stays there. And I'm gonna specify that this is the raw CBOR data, and this is the current position to read from. And we, this started 0, it's obvious. And yeah. And I don't think we need to worry about uint on or whatnot right now. I mean, it makes sense to make it uint at least, right? Just so that we don't have weird stuff. So okay, that makes sense. And yeah, it's not like we're gonna be dealing with little gigabytes coming and requests for a nym library or something from Surreal, so good enough. Okay. So now let's just make a proc new CBOR reader. We just need to give it, let's make it a open array of bytes. This way we can pass either a sequence or a actual array if by any chance we have an actual array. Okay. So do I need to do data.to sequence or something like that? And Tara says, let's start with getKind function. What do you mean by getKind function? You mean to read the first header byte, right? Yeah, of course, we'll need to start with that. I just need to do one thing that I usually don't like about nym is that right now I don't get absolutely any checks if this is fine. So I need to actually go here and say, you know what? Import this reader file from there. Okay. This way I'm gonna get errors like, hey, there's no such thing like to sequence. So I need to do import bitops. What is bitops? I'm liking that. AI is already hinting at us, hey, you'll be able to do that. So yeah, Tara's suggesting let's start with getKind function, which is absolutely, I agree, because this would be a function that would allow us to read the first byte. And they were referring to it in some way in a specification, right? Okay, it's gonna write again. Sorry about that. I didn't write the documentation. If I would write documentation for CBOR, I would make it dark mode. Was it head or something? Because there's initial byte. There head. A single encoded data item that follows the head. The initial byte and any additional bytes consumed to construct the argument are collectively referred to as the head of the data item. Okay. So that's what I would like to do. Basically return the head. Because depending on what is the value. So the role of the reader, in my opinion, would be to make sense of the raw CBOR data so that we can say, you know what, read the head, and it can figure it out automatically if we just need to read the first byte or do we need to load the other bytes. So I would say proc read head. Okay. And, you know, we call it on the CBOR reader, right? And we don't return just uint 8. We would return major and then uint 64, because very likely that's what we would read. And this way would be able to handle the value no matter what happens. Task says maybe major type first. I would say we just return it in one read, right? Because the thing is that when we read from the buffer, the major, grabbing major will just return like, oh, this is just those 3 bytes. That means we need to keep those and kind of chain it with something else. I think this will be good enough to just temporarily store the uint64 value, right? Because we just return it as a tuple. We have very simple type to take care of. And I would just create a CBOR new file, major.nym, and I'm just gonna say type major, which is range from 0 to 7, I believe. Let's see if that's gonna work. Import major. Save. Okay. And major is fine. So a value of the major type. CBOR type. Okay. Just shove the word CBOR everywhere. So that's what I would do. Reads the head of the CBOR data, the major type, and the initial byte and additional bytes, and the argument or additional bytes if necessary. Because outside of here, we don't care. Outside of the reader, we shouldn't care about, you know, how many bytes it takes or whatever. It's just give me the damn value. Okay. So we need to extract the first byte. So, so extract first byte, then will be read value of read the first 3 bits as a major type, and then it's gonna be argument and decide if more bytes are needed. Okay. So we can extract, right? First byte. Reader data is just that. Okay. And here we can already advance the increment the position because we just read it already. Okay. I think we could actually make a simple proc read byte. Or sure, let's just make a read byte and reader data length. Unexpected end of CBOR data. Sure, let's not do that. Let's just go crazy and not even run those checks. Let's assume that it works, and if we're gonna get error, we're gonna handle it outside of here. Result is this increment, and there we go. And Taz says there could be also value in a dumb reader, which provides functions but no business logic. You can build smart reader anytime on top of dumb reader. Yep. And then we just made a dumb reader to read the first byte, right? I mean, I get the implementation. I understand how the protocol works, and I don't see any problem in, you know, making it semi-smart initially, because, you know, I don't see it being relatively complex, especially the reader, writer, the whole encoding and decoding, that I can see as a simple exercise. Now, after the specifications and the other things, this is going to be simple. I know that later, the difficult part will be, at least for me right now, because I don't have enough knowledge about it, will be to figure out, okay, I can read all those data types, but 99% of time we're working with a database, you want to load it into some kind of custom type, or take your custom type and convert it automatically into, you know, those types that are supported by SurrealDB. And that will be the difficult part, because this is where the magic comes in. And I have ideas of how to approach it, especially conversion from existing type into, into CBOR. That's gonna be easy, but the other way around, uh, not sure yet, especially without putting a lot of work on whoever's gonna be using the library. Because eventually I want to have it like, hey, something like, let the user, oh no, let user of type user, right, is await, uh, database dot select of the type user, right? That's what I want to extract it to, and I'm just saying that it's gonna be user Ben, right? That's what I would like my code to look like. And the difficult part here, the select, it just grabs that from the database, and decodes it. But then it somehow needs to magically fits it into a user. I can easily make whoever's writing this code, whoever will be using my library, oh, you know what, you need to, let's say, you need to make sure that this has that procedure implemented on it, and then it's fine. Something that takes, let's say, this SurrealDB node that will tell you what kind of data type it is, and you can write your own code that fits the data into the user. But at the same time, it would be nice to have this, happen automatically. That, I know, code will write itself for you to figure that part out. Okay, so we have the first byte, and for that we just say reader dot read byte. Okay, we've got that. We've got our first byte. We've got it here, and it's a byte. So now we just need to read the first 3 bits as a major type. So let major is Oh, I see. But no, that's not it. Or is it? Because this will take the first byte, right? And basically the AND will make sure that only those 3 bits are being used. But will it convert it to actual values 0, 1, 2, 3, 4, 7 or something? That's a good question that I'm not sure about right now. So let's do this. I'm gonna do return ob whatever value is 6 dot major, and then the second one will be some kind of so whatever 1 to 3 dot uint 64. I'm just gonna return that so that we're gonna have that part. I'm gonna ignore everything else because I want to run some tests of them. And that says, by the way, thanks for reading CBOR specs for me. It is now clear that this is awesome transform layer data protocol. Yeah, I'm liking that too. It's like really seems really easy to serialize. It really is concise. Yeah, I'm liking that too. And I like the fact that you can actually add all of those gaps inside and make them, reusable parts and whatnot, because it doesn't have some internal dependencies of this versus that and whatnot. It's real simple. So, I'm thinking, yeah, let me just get ChatGPT. I want to not learn about stuff. Because I remember doing bitwise operations early on while learning programming and stuff, and because I usually was doing more high level stuff, I never really had never ever had any need to do any bitwise operations. So this is somehow something new for me. So let's go to the O1 preview and say, I need some help with bit operations in NIM. This is my code. Okay, I'm just gonna give it my code and we're gonna ask it to implement it and explain with examples. So we're gonna grab that. We're gonna paste it and we're just gonna do that. Extract first byte and we'll just say that this is uint 8, right? Let's say uint 8 for byte, because that's an equivalent, right? So we're just gonna say that it's that, and we're just gonna put an enter here. Then we're gonna say to do, and we're not gonna do anything. So as uint 8 value from 0 to 7, just to be a little bit more explicit, and then to do with the next 5 bits as uint 8. Okay, value from 0 to, what is it, 31. Yeah, I don't know how necessary that is, because we could kind of do things table wise, but I want to learn a little bit, and then it will be that's it. Okay, and I'm gonna remove the return type because we're not worrying about that right now, and we're gonna say, we've got that part. Please implement the to-dos and explain how the bitwise operations work with some easy to understand examples. There we go. Let's just see what the hell we're gonna get. I'm happy for the opportunity to play a little bit with this O1 preview to see what kind of result we're gonna get. So certainly, let's implement the to-dos in your code and explain how the bitwise operations work with simple examples. So let's see what it made. So reads the head of the CBOR data. Okay. So first byte unchanged. Read the first 3 bits. So this one has different approach. Major type, first byte, shift right by 5. Shift right by 5 bits to get the top 3 bits. Read the next 5 bits as uint. So this will be, okay, we're just masking them. Okay, I see. I like that. So I like this approach way more because, as far as I know, you read from right to left, those bits, right? This explanation of bitwise operations allow you to manipulate individual bits within a byte or a number. In your case, you need to extract specific bits, major type, and additional information as per the CBOR specification. Shifting right, this shift right operation shifts. Okay, so shifting right by n operations. divides the number by 2 to the power of n. Okay. And so the top 3 bits are moved. Okay, so that makes sense, right? Those 3, we're gonna move them by 5, so we're gonna end up with 101. So 101, which is 5 and decimal. Great. The next 5 bits, so we just mask them, so we ignore everything that is 0 is gonna get ignored. Okay, so that is actually great. First byte breakdown. Yeah. Okay. Cool. I like that. This is really simple. So let's just copy that code because I like it. So the thing that we're gonna do here is first byte, read the first 3 bits. Yeah, and let's say this will be uint8, and I'm just gonna specify as uint8. Because this looks a little bit more nim-like than anything else. Read the first 3 bits as as major type. So major type is what the hell is gonna return? I hope it's gonna return uint8, right? uint8. And okay, read the next 5 bits. So we've gonna, which is basically the argument. Major type and argument. There we go. So we just mask it. Okay, that's obvious enough. And then we get to the point where we need to decide. But now I'm wondering, how do I do that? Because I read the first 3 bytes. It's guaranteed that the first 3 bytes just simply mathematically cannot be a different number. So I can just straight up convert it to dot major. I hope. It's complaining. Type mismatch. Expected uint8. Oh, yeah. Major. Save. And now it's not complaining. Okay, great. So I don't even need that. Great. So we got the major type as the major. That means that we can exhaustively iterate through it. Or like do the whole switch, and it knows that it's only values from 0 to 7. So that's great. And then we have the next 5 bits. So that's great. And I believe we could actually make the type as well. New file. Argument. Let's rename the file to types. Okay. So it'll be CBOR major. Or like head major. Head major. And then we've got the head argument. There we go. Beautiful. So here we can just say that it's type argument, or like CBOR argument. And we import types, right? Oh, head, not CBOR. Okay, cool. So we've got the head argument. I mean, in theory, if that would be... No, we don't have any type that doesn't need that argument. Every type needs that argument. Okay, so there's no way to avoid that. Okay. Taz was saying and overlay flexible. Overly flexible. Okay, yeah. Okay, so now we actually need to look a little bit into the thing. And return, this will be the major type. We already know that we're returning that. So let's take a peek at specification. Warning, do bright light. Okay, so we've got that part. So major types, 0. An unsigned integer in a range of this to that. The value is encoded. Okay, do we have that list? Integer n, integer that. By the way. So an unsigned integer. The value of the encoded item is argument itself. For example, the integer 10 is denoted as this. Integer 500 would be this. Major type 0, additional information 25. Followed by the 2 bytes. So this, without content means without the additional stuff. Okay, so this is where we need to look at those, right? And do we have any of those major types that say that we don't even care about it? Those two will define how many bytes, right? And the byte string will also be doing that, right? So for byte string, the number of byte string is equal to the argument. Okay, a string containing an... Okay, to the argument. So again, the argument value decides if we need to load up more to describe a larger number. Okay, so that makes sense. The string is going to be exactly the same. All right, 5 for the length or 500 for the length, which will be 25, 2-byte array. Perfect. Array of data items. So this will be the number of items. Okay, that could be any number as well. 5 is the pairs. Again, we need that. Major type 6, a tag, data item tag. And here, okay, and here again, the tag number is the argument, right? Tag data item, whose tag number, an integer, is the argument. Okay. And then floating point numbers and simple values, as well as the break stop code. Okay, makes sense. So I don't think we really need that specific head argument. Okay, I'm gonna comment that out for now. Something tells me we don't even need that. We'll just handle those specific values and everything else is gonna be like error. So in our reader, we just have this, right? And let's just make sure that this is a uint 8, just like the rest was, right? No big deal. Got the additional info. So this will be the argument. Okay. So bits. So let's do let argument, which will be uint 64, is, and we do basically case or argument bits. Okay. So let's make the case of 0 to 23, which will be just that. There we go. Whoa. Oh. if we have a value of 24, we read the 1 byte, right? Less than 24, 24, 1, 2, 4, and 8. Okay. So read byte, there we go. And 25, that means we need to combine those two values into a number. I see. Huh. How could I do that nicely? Because this is, again, not something where I'm used to. Because it says this or that. So or will basically combine them two as bitwise operations. But what if, because this is not the first time I'll be reading 1 or 2 bytes as some kind of specific value. So I have, where did I have it? Read byte. So let's do proc read 2 bytes. Does that make sense? Read 2 bytes into that value, right? And I would like probably the approach of shift left. Right? Yeah. And I would like to do it without calling the other one here. So let's say result is uint, wait, reader data position thing. And let's make it as uint 8. Okay. There we go. Much better. We don't have a constructor for it? Oh, we have. It's just wrong spot. So we read 2 bytes. So we got the first byte, right? Let's do u and 16. How do we add them actually? Is which order? I guess shift left 8 or this and then increase by 2. I think so. Task says, I don't think that in all major types you should interpret 24 or bigger as instruction to read more bytes for the header. Yeah, not in all of them, depending on which type we're dealing with, right? But then we will have just really ugly tree of if it's this type, do that. If it's that type, do that, and million things. While we could just make combinations prohibited or something. Personally, I would just make it a bit more permissive. If something doesn't make sense, but it's probably encoded. I don't know. I think what you're suggesting is actually not dumb reader. What you're suggesting is a really smart reader. The one that is aware that, okay, this shouldn't really happen. So right now what I'm thinking is if I'm reading those 2 bytes, the first byte will be representing the bytes to the left and the one to the right. So I get those 8 bits, shift them to the left, right? And then I'm adding the extra 8 bits on the right, I think. And therefore I can basically increase the position to the right, and that should be it, I guess. Tara says they have a table in RFC. I feel like it tried to implement too much for a single function. Really? Read the head and if argument, just leave the argument. And as we get the value here, which is read byte here, read byte to uint64, right? That's what we're returning. Then of 25 will be read 2 bytes, 26 will be read 4 bytes, 8 bytes, and everything else doesn't make sense, right? Because these are reserved, and everything else is just sorry. The only version will be the 32, which would be dependent on which kind of value we have. Or is it? Huh. Yeah, that suddenly complicates it. Tara says, I would just read first byte and be done. I will leave 24 and other cases to the user of read head function. Yeah, because now I'm thinking you might be right. Because now we're encountering the situation that, you know, if it's between 28 and 30, we just raise a new exception that, you know, this shouldn't be used. And if we have 31, that could basically make it so that which case was used? An argument value is derived. In the major type 0, 1, or 6, the encoded item is not well formed. And for those other types, it's considered to be the break. So I think we should just make the read, the read head that you said set as that, and then basically have a check, something to check if it's break. If not, something that extracts the actual argument out of that head. Okay, that makes sense. All right, that makes sense. I can see how it can be used. All right. So we need to go back to types, and we're gonna have this head argument defined here. Okay. Therefore, argument is basically this as head argument, and we just return this. And we are not even doing that. We just have the and that will be somewhere else. Okay. Okay, so this will be the read head, right? We don't even need those comments because this is that obvious. Okay, that makes sense. So then we have proc is break, where we would need to give it a value, let's say of the major type and the other stuff of the head, which is tuple of major and argument. There we go. And we just get true or false. Check if the head is a break. Suggests a break of indefinite sequence. Okay. So If it's 7 and argument is 31, we say yes. There we go. Otherwise, we'll have proc read get full argument. Okay. Which will be, and the head doesn't matter. We just need to provide it with the short argument, which will be the head argument. And that will give us the full thing, which we're basically saying that result is case of short argument. So of 0 to 23, it was basically this. Of 24, reader read byte has this value 2 bytes, 8 bytes, and note that of 28 to 30 will be or just else, the exception, valid argument. And that's it, because if we want to accept break, we just need to explicitly ask for that, otherwise not. Okay, all right, this makes sense. I know that you're probably upset about this specific code, Taras, because you would probably do it differently, but that's how I'm rolling now. And I'm gonna nicely indent them so that it's obvious that it's part of that. Okay, so we just need read 4 bytes and read 8 bytes, which I'm not happy about, but we're gonna do that. Okay, so proc read 4 bytes. Okay, that will return you in 32. And what we're doing here is simply okay. Taras said I was thinking more about defining functions like read int or something like that. Read negative int. Sure. I mean, that makes sense, right? I'm just naming them differently. So I'm gonna call the read byte because, or should I make read uint 8? Uint 8. Ew. There we go. And do I have it anywhere else? There we go. And we just converted to that one here because we have to for that purpose. So read uint 16. Okay. There we go. We're gonna go make everything in that way. Sure. Reads 2 bytes from the CBOR data. I mean, gets a single 5 as a uint 8. This will be two bytes as uint 16, right? That makes sense. And then reads as uint 64. So wait, 32. Geez. So we can format it nicer, right? Than this weird thing. Come on, AI, stop with those. Oh, it's not even AI. Result is. So we've got this. Or that, or that, or that, right? There we go. And Tara says, it is really easy to lose yourself in this RFC. My head is going circles. I love your persistence. Well, that's what the streams are for, so I can actually accomplish something in my life. You and 64, which will be even more fun. Yeah. Hey, this looks good, right? I don't like it, but it looks somewhat okay. Although it doesn't like the few things here. So it's complaining here, expression expected by found keyword or. That wasn't like Godot where you could just slap something at the end, right? Can I do that? Yes, I can. So I just need to put or at the end. Okay, that's doable. Okay, now it's not complaining about that one. Great. Says your life is impatiently waiting for your streams. To some extent. Although I must admit, sometimes I'm just like, oh, I wish I wouldn't have to do that today. But at the end, it turns out often to be like, you know what? This felt good. Okay, this should be good, right? Okay, this is good. I don't think this is like the most efficient way to get it, but possibly it's gonna work, okay? Possibly. I'm not 100% sure. So, okay. So we have read UN16, read 32, and here will be this part, okay? So those that we need, we have implemented. And anything else will be like, oh, sorry, you really did bad. Okay. So, do we need anything else from here? Not at the moment. We'll implement things as we go. What is bit ops? Because I want to see bit ops. Because maybe this is some magical library that's gonna change my life. Bit ops provides a series of low-level methods for bit manipulation. This module implements a series of low-level methods for bit. By default, compiler and intrinsics are used where possible to improve performance on supported compilers, GCC, and all those. The module will fall back to pure nimprocs in case the backend is not so. Oh, okay. You can also use the flag no intrinsic bit ops. Okay. So what do we have? Bits range. A range with all bits positions for type T. Okay, bits range from here to here. So how many bytes we have? From 0 to however many bytes we have times 8 minus 1. Okay. Oh, so this is a range of bits. Very interesting. Bitnut computes the bitwise complement of integer x. Okay. Bit slice mutates v into an extracted and shifted slice of bits from v. Bit slice, and we just give it a range, and it's gonna be that. And what does it return? Oh, it just modifies it in place. Bit sliced, it just returns the type of those bytes. So what the heck? Mutates, clear bit, clear mask, and clear mask. Count leading 0 bits, count set bits, fast logarithm, first set bit, returns the 1 base index of the least stable. The moment I see something like bit operations, I'm just like, ugh. Just kill me. Ay. First set bit, flip mask, flip masked. Okay, so I presume they this tries to call some backend stuff like straight on a compiler, or it tries to probably optimize it to straight CPU operations rather than what I'm trying to do is do manual stuff. So go to mask, so we can do mask and this, right? Okay. Mutates V with only the 1 bits from mask. So mask, do we have masked? Yes. Returns V with only the 1 bits from mask matching those. Okay, so I guess we could effectively maps to bit and operation. Okay, so we just have bit and as macro. Huh, let's try to use that. Because we have bit ops already, and we use that somewhere here to mask those things. So it was here. We mask them here. So we do first byte masked. Okay, so we got our first byte dot masked, and wait, not here. Where the hell was I? Here dot masked, and here we are specifying this as year and date. I guess that matters. Okay. All right. Because we don't want to. I mean, which is better, to do mask or masked? Not sure. But okay, we've got masked. Parity bits, pop count, count set bits, Hamming weight. Interesting. Reverse bits, rotate left. We don't want to rotate, set mask, all that stuff. Test bits, return true. Okay. To mask. Create a bit mask based on a slice of bits. Okay. And we have AND, OR, XOR, flip bits, set bits. So we don't have shift left and right because I guess we already have operators for that. Okay. And here we're doing a bunch of those. So I don't know how to optimize those. I just don't know. A bit AND computes bitwise AND of all arguments collectively. Oh, and we can provide a bunch of stuff. Huh. So I could do bit and comma x y t and then additional ones. Okay. Sure. I just do a bunch of commas and just call it that way. I have no idea what I'm doing. But this says it's performant. So I'm gonna trust it. I learned to trust Nimdocs. Okie dokie. And this will be again bit and I'm just gonna format it in exactly the same way for the sake of consistency. There we go. And we don't need to do anything here. So that's possibly good enough. Possibly. Yep. Okay. Um, I'd assume that this is good enough. So that's our reader. We can just start reading those things. And I don't see any reason to do anything more at this point. So let's make some kind of quickly because I have not a lot of time left. I'm actually thinking that I might finish like in half an hour and I might stream for maybe 2-3 more hours tomorrow around 10 of my time. That sounds like, I might have a chance to do that. That could be fun. Decoder them. So how did they approach the decoder on this side? Because in TypeScript, Taras says I'll be sleeping soon. Yep, that's my plan too. To finish in half an hour. Okay, so they're tracking of the array buffer right here as the reader. But I want to see the decoder. So we give it something that decides if it's an object or a map. What the heck? And the magical replacer that is supposed to replace some partial stuff, I believe. So the code basically takes input as either a already existing reader or an array buffer, and then we got the decode options, which is an object or map. Oh, so basically, if we want to, here is decoded to JavaScript object or a map because these are two separate types. Of course, that makes sense. So then we've got this thing options, and we basically make sure that we have a reader with that array buffer. And besides the inner, we have just the code and just run the random replacer that we won't worry about yet. And here basically, extract those two, and depending on major, define if you need to read the whole thing or not, and just return a specific types. Okay, I see. So this is gonna be extremely simple. Says the accept PRs replacer could be a hack to providing support for custom tags. Possibly could be, and of course I accept PRs. 100% PRs accepted. That's why everything's open source in the first place. So 7, it's a tag. Read the length, and then decode the value and create new tag. Okay, it just returns the type tagged. That's all it does. It doesn't touch the replacer because it calls the code, which we'll call this one. Options replacer. If there's a replacer, options replacer, and calls the thing. No idea how replacer is being used here. If I'm gonna find all the instances of the code, CBOR.ts, don't care about that. CBOR test, that's the only place where we call the code. What? Code encoded. Okay. do we get any actual usage of those things to replace? The code, partial, build. Not here either. And not here either. It's as if we're not ever setting any settings on the code. That might not exist. So the decoder, it doesn't even need to be any specific class or anything. It's just a function, right? A procedure. Proc decode, and we can call it on basically data, which will be open array of U and date, right? So, and we're gonna return for now true, that it's always true, okay? Just for now. Tara says, could be a copy paste from another project. I believe that's what it is. A copy paste from another project and then stripped down. Because I think there is a, initially in SurrealDB, they were looking at an existing solution for CBOR. There was a package of some kind of CBOR for JavaScript, but it was really, really slow. And I think they stripped it down, modified it a little bit, and there are some leftovers. And they will be rewriting it eventually. I already asked those questions. Okay. So eventually just return true for now, because we can't really define what we're returning yet. So we're going to decode, open array, and 8. So we just need the reader. So we're actually going to do return the code, new CBOR reader with the data, okay? This way we can actually define proc decode that takes the reader, okay? And this is where we're going to implement the actual data. Okay, this way we can have the overload and whatnot and make it all fancy and whatnot. Blah, blah, blah. So with the decode, they implement it in a way that they have that inner thing, right? And that inner thing has access to the reader from the context, but I don't like that. So we're gonna do that proc decode inner. And we're not gonna export this value. So we need to, of course, pass it the CBOR reader. And I don't think we're gonna actually have just decode inner. We're gonna have it, yeah, we're gonna have decode inner and then some specialized aspects of the thing. So basically, what do we call it? Do we even need the inner? I don't think we need that. Because the whole thing that the code will do is basically, you know, let, what do we do here? Come on. Sure. Major argument is read the head, right? And then, case of head major, what did just happen? If we have 0, it will be the, you know, unsigned integer, right? Then we're gonna have of 1 will be negative integer. Byte string, text string, array, map, tag, and simple value. Okay? And if I would try to do the 8, this will complain because head major cannot contain number 8, which is fun thing. Okay, all right. This is good so far. So I'll just do, hey, to do. And we'll just add this card at the end. Okay. So I'm just gonna bunch of those. And we're just gonna add a bunch of to-dos. Okay, so we got a bunch of to-dos, which is great. So, yeah. All right, see you around, Taras. Have a good night. And thank you for helping out. I really appreciate that. Thanks to you, I went through those things a little bit faster and yeah, I think you pointed him in a good direction. So thank you for that. Okie dokie. So we basically, depending on that head major, we need to figure out, okay, for this one, for the unsigned integer, first of all, we need to get the, let full argument, just get the full argument out of there. And basically, we're going to return the value, right? So it will be to do, return the value. But the whole thing here is that we can't just return a value because nim isn't so dynamic like JavaScript where we can just return something and yellow, right? We need to be able to specify something. So for that specific reason, I already started somewhere specifying surreal types. The possible types that we'll be able to return, okay? And I'm gonna straight up comment them all out, okay? And we're gonna start from the beginning. First one will be the integer, okay? So surreal integer. Okay, that'll be the first thing. And what that means is that we can create surreal node, which just is a type that will be able to contain any type that is supported by SurrealDB. And this is what we'll be able to feed it to. So let's create new file, node.surreal node. Do we want node? Sure. .nym. Let's do surreal value. Okay, that kind of makes a little bit more sense. So we type surreal value, which will be, do we want it to be an object or ref object? I'd say it should be reference object, so we can pass it around with copying all the various potentially massive amounts of data. Okay, because it's not gonna be that obvious which is when. So a SurrealDB compatible value. This can be serialized to / from CBOR. Okay. So we'll have the case kind of surreal types. So this is where we do import surreal types. And this is basically where we can say that, hey, for that specific node, if we have the surreal integer, we are storing the int64, okay? And that's the only type we have right now. So let's just have that here. And in our, where is it? No, we don't, not touching that. We're not touching the I mean, serial types will need to live here. So in the decoder, if we have the unsigned integer, we should be able to just, create that value. So what I will also do is just make a bunch of ways to do it, right? Proc new SurrealInt, right? And this will be takes integer 64 and returns a surreal value, okay? Sure. So this will be returned this with that kind. Okay, so this way we can kind of start moving forward a little bit, okay? And in my opinion, this should be so first of all, this needs to be uint64. Haha. Yeah, it needs to be uint64. So yeah, so the thing is that the CBOR allows us to make massively large numbers no matter which direction. So yeah, this is not fun at all. We would need to basically do bool. I mean, int is negative. Okay, we just need to provide that value to be able to tell is this a negative value or not. This way we can convert it to and from CBOR nicely. Okay, I have no idea how we're gonna convert it to different numbers yet, but we'll see. Okay. So let's say new serial integer. If we're gonna give it uint64, or I'm just gonna do it as uint 8. I mean, or uint 8 or uint 16 or 32, whatever. If it's whichever of those types, just this dot uint 64, and is negative false. Okay, just something like that. So now in our decoder, we can just say import, and this will be the types surreal value. Okay, there we go. And do we need import reader? Yes, we need to import reader. Import reader. So we also need to get the decoder in here. Decoder should load the other stuff too. Okay, we got the decoder. It doesn't complain about that, and now return value will be basically return new SurrealInt. Okay, and that will be basically the full argument. Okay, because full argument returns uint64. Got surreal value. Okay, and we need to return surreal value. Okay, that's what we're expecting to return. So this is happy now. Okay, because this is an unsigned integer. We're good. So the thing is that I want to complete this on the side of surreal value a little bit, okay? Because we have the new serial integer, and we should also provide a similar one with new surreal integer where we are providing not unsigned integers, okay? Just normal ones. Here we basically need to specify which one this thing is. So now how the hell do I make it properly unsigned? I think we should be able to find something, right? So ABS absolute value or because I want to find something without a sign. That's the thing. We have complex and other stuff. Um. I might have seen that at some point. So I'm gonna try something. I'm gonna go to the system because maybe there already is something here. Where's the system? Oh, here. Okay, I've got the system. And we just have iterator, exceptions, assertions, dollars, and C types. I don't want that. We have sequences, sets, numbers. Should right and orgs or not, to int, to float. Okay. Ordinals. It's not reversed, all that stuff. So, I don't like that. Can I just do this thing? Copy everything? Ooh, okay, that is a lot of stuff here. I don't think it's gonna be able to help me out. New project. Wait, I have actually a test project here somewhere, right? Temp. There we go. So we're gonna add contact, and this will be list of name procs and let's do system module. Okay, just gonna paste this. This is a list of all of them, right? Add content. Is there something in the system module? Is there some that suggests to be a function nym procedure that removes a sign from an integer value? I know it's really super easy, but there doesn't appear. However, there are a few functions. I mean, ABS. Oof. So yeah, I would basically need to do the ABS, and then make an if whatever for here, if it's true or false. But because I'll have that true and false, I can already use that, right? So if value is less than 0, we're gonna take the negative value, and I don't know if I need to do that or not. I think I have to. The negative value, because it is less, so let's make it positive, and is negative true. Otherwise, we just do that. Okay, I think this might work. Okay, that will be good, and I will also copy this and surreal negative integer, just because it's theoretically possible. We're just gonna say to true, and this way we have ways to create those integers. Okay, but additionally, instead of just saying, hey, new surreal this, new surreal that, it's just all this stuff. I would like to have, instead of, because this is new, let's just call it, all those new, we're gonna replace them with 2, okay? 2, surreal integer. So, creates a new, no, this will be converts. Converts an integer to a surreal value. Okay, there we go. All right, this is good. So this way we can just basically say let some value is 123.to surreal end. Okay, and we're good. Not the prettiest, but it works. Now, is there some kind of symbol that SurrealDB uses a lot? Because I'm thinking that there could be also an operator that takes any of those values and automatically knows to convert them to integers. And floats will convert automatically to something else. Proc whatever. This will be to surreal. I don't know. Let's say something like that for now, right? It takes the value, right? And splits surreal value. Okay. And this will be the same thing here. And that's it. And this way we'll be able to call that operator on whatever we have to. Okay. And because of that, we'll be able to support the same operator on various different types of values, and therefore this will be our new operator for just convert this to serial int, and it should cascade and whatnot and whatnot. So we'll see how that goes, okay? But yeah, that's integer values. We have that done. I mean, we should also have the other way around, right? Proc to integer, okay? Huh. So we would basically need 2 and u and 8, right? So how can you approach that where it's actually safe to call that? Because there could be many ways. One thing is that we want it to be easy to call. Like, hey, convert this to that. Yeah, let's do it just this specific way. If you're sure that is the value, you just call it. Otherwise, you can check yourself if this is actual integer, if it's this, or if it's that. So if it's not, exception cannot convert non-integer value to that, okay? Then we're gonna have if value dot end is negative. Okay. Okay, this will be just painful. And then if value dot end value is larger than this, yeah. And then we just return it. It's a bunch of checks. Very ugly, but we might as well go with that, right? Okay, this is good. Can I do u and 32 dot high, right? Because that's the highest value. So I can take that dot high. And this will be u int 8 dot high. There we go. This could use some kind of, I could use a template to generate those, but for now it's good enough. TUN64. If it's not integer or if it's negative, problem. Otherwise, just return it. So that's good. Proc 2 int 8. Okay, so now we're entering the outer realm where it could be positive or negative. 2 and 8. So if value kind is not integer, of course, and so we're not checking if it's negative or not. So we have to check if value dot end is negative, and so if it's negative, okay, if the value and value is less than u and 8 dot low, okay, so it's not within the lower range. Can I convert negative integer value greater stored value is too small to fit in there. Else if value is larger than larger, too large. Otherwise, just if it's negative, I need to check if it's we'll do the let negative value is because this is not actually that simple, huh? This is surprising because the serial value is storing a positive value no matter what, and we have just a flag to say if it's positive or negative. So basically, if it's negative, I can just do weird stuff like that. I would need to say, hey, this to int 16 or even 64, because why not? This whole thing. I flip it. And then I can compare it. And I can't just make the same comparison to this value versus that value because they also differ slightly depending if they're negative or not. Let's think. Because the other approach will be to first check if it's within the range, right? So if value dot end value is larger than this height, you know, as this thingy, minus, and here we basically say if negative, do this. So you have this whole weird thing. To say, okay, so this is the maximum limit. So I could make it probably a const. So it's statically compiled. Max int 8 is I mean int 8 dot high, right? Const minimum int 8 will be int 8 low. And I'll be comparing to int 64. So let's do int 64. I mean u int 64 and u int 64. Okay, minimum u int positive. So they will be both u int 64. So here I can just say u int 64 and that'll be fine. I'll convert it, no problem. Here, I kind of can't do that. I need to do int 64 and then say inverse it and convert it to u in this. Although I could easily convert this to from negative to positive. Okay, because it will be up to 228 or 7. Basically, the lower number I believe is smaller. Let's actually search that because I'm starting to get confused because this is the one edge case scenario. And 16 range. Okay. Oh, the negative is actually larger than positive. Look at that. So you can see that positive number is one smaller than the negative. So we need to do dot int 16 to fit that value. And only then I can grab it and convert it to this value. Bunch of parentheses because I'm not sure how it's gonna run in what order. But the good thing is that these two values will be compiled during compile time. So then I can say value is larger than if value is negative. There will be minimum else max. Okay. So if it's larger than say star value is does not fit in an int 8. Okay. This way I'm just adding that check. Okay. That's that. We just checked if it fits. And now we just need to convert it to proper value, right? So we want to 2 and 8. So if that value was outside, then, but if it's within, then we can just say return this times, and basically if it's negative, just times -1. So in value dot and 8. Let's actually do this and convert it at the end. There we go. And what is it not happy about? I guess I need to wrap this here. There we go. Return. What? because we erase it here. Other than that, we try to return this times this dot and 8. What? Ill-formed AST. Holy moly. What on earth is going on? Oh, because I have to actually do this dot and 16. There we go. Because I couldn't multiply this by -1 if it was uint 64. So 16 will contain both numbers, and then we can reduce even more. Okay, because if I would convert it to uint 8 here, I could cut off the largest possible number. Okay. Gosh, this is confusing as heck. 2 and 16. It'll be basically the same thing, right? We do the same thing here, it's just whenever we have the other number. So what I'm gonna do is actually copy this and run basic replacements, because I'm not sure if this is all gonna go well. Well, maybe I should have done this. 16. Yep. Yeah, 64 and 16. This is larger. There we go. That's good. I think that's good enough. So then we have 32. Then 32. There we go. Okay, this looks good. And then we have 2 and 64. So the maximum value is this to here. And then minimum and 64 positive is we get the low number. It already is in 64. We flip it to and this is gonna be a problem. So I mean the positive should be int 64 dot high minus 1. Uint 64. I guess that's the correct answer too. And then we just do our comparison. Okay. This should be good enough. So we've got those two uints and normal ints and all those things. So this is getting a little bit complicated, okay? So I think I'm gonna move those things around. Instead of types, we're gonna have a separate folder. It'll be surreal values, okay? Or do I call it values? I don't like it. I mean, things like those values, they will need to be exported out. but we'll take care of that later. So surreal value, yeah, inside type, we're just gonna new folder values, new file, which will be integer values .nem or integer value.nem. There we go. So that means I can just get all those integer related things out of here, plop them here. Okay, great. And therefore, I do import values integer value, and I'm also gonna export it. Okay, this way, you can just import a surreal value and get all those nicely. So that's good. Integer value is unhappy about something. Oh, because we need the whole. Oh no, they depend on each other. Oh no. Oh no. Okay, so what we're gonna do, because this depends on surreal value as well and all this stuff. Yeah, this is gonna be sketchy. So instead of doing all this, we're just gonna do straight up include. Okay, this should solve some of our problems until we'll encounter more, and then we're gonna take care of them. Okay. So we just included here, therefore we still just imported surreal value and be able to use it everywhere. So there we go. We take the full argument to surreal int. There we go. Just like that. In theory, we can actually do this. But I'm just gonna make it do less guesswork and nicely to surreal int. And the same thing will be with negative integer. Where we're gonna do, so this is unsigned integer and this is negative integer. Let full argument, let's read it. Okay, surreal negative integer, and there we go. Okay, all right. I think we took care of two first ones. So that's where we're gonna finish for today. Alrighty. I'm gonna make that. This is gonna make it happy, and we're gonna make whatever. We just make it for now to surreal integer. Okay, just like that. For now, this should make it work. And to make it faster, there we go. Even better. So yeah, that's where we're gonna finish for today. So let's push that code. It's on a CBOR branch. And we're just gonna make it what? We have constants, decoder, encoded, for now at least, reader, tagged, types, surreal type, surreal value, integer value. Great. So this will be start implementing CBOR reader, decoder, values. Okay, there we go. Let's push it. And that's it for tonight. So again, thank you everyone for watching, And if you like the content, consider liking and subscribing on YouTube or following on Twitch. And you can also join my Discord. Link is in the description, probably in a Twitch bio where I need to update it, or below on this little bar here on the bottom. So again, thank you for watching and see you soon.